living on a disk, floating through space, with a tiny sun.
Hey, I'm FTFE and welcome back to the channel that most definitely did not cut the brake lines on Stupidity's car. Oh, oh God. Yeah, I didn't cut the, honest, I didn't, I promise. Anyway, yeah, welcome back to another Monday Night Debate, guys. Tonight we have back on the channel, Sunny, who was on the channel a couple of days ago with the incredibly obnoxious handlebarred mustache moron that is the Plain Truth. The Plain Truth rage quit, however Sunny hung around and actually had a pretty decent conversation with me, so I thought I would bring him back tonight to have a one-on-one. So, Sunny, welcome back to the channel. Thank you for joining us once again. How are you doing today?
I'm doing great. Thank you so much for having me back on.
Yeah, I just want to say before we get started, on your YouTube channel, as you go to the homepage, there's a song that you have, and I hate you because that is stuck in my head. Sunny isn't just a flat earther, guys. He actually has a YouTube channel that's had quite a lot of views, and there's a couple of songs on there, especially the one that's on his homepage called I Am a Loser, that is really cool and funny, and it's got cool animation that he uses Adobe Animator to make. His YouTube channel link is in the description, so I encourage everyone to actually go and check out Sunny's channel because I've had a great time looking through the stuff that's on there. So yeah, no worries. Thank you for coming back. So
no problem.
Basically, to start with, I'd like you to kind of reintroduce yourself in case any people didn't see you the other day. So I'll just give you the floor for a few minutes. Introduce yourself to people. I'd like to tell them why you became a flat earther. And what you think your biggest evidence are as well. So over to you.
Okay. Well, my name is, of course, Santosh. I like to call myself Sunny because it's easier for everybody. And it's a fun name. So I am, as I mentioned before, I'm into multimedia. That's pretty much my profession. I freelance a lot, build websites, do graphical works and animations. And yeah, I became... as I mentioned, I was always a truther. I was kind of into conspiracy theories, the old Alex Jones to an extent. And then Flat Earth was always kind of like poking at me. Like they would like, Flat Earthers would always leave comments about the Flat Earth. And in the beginning, it always annoyed me. But I thought they were just a psyop to take people away from the actual truth that's happening, you know. And thankfully, I looked more into it. And of course, I looked into, I was raised as a Christian, so I did some research on what the Bible actually says about the Earth. And in the beginning, when I was during my atheist days, I thought it was just, you know, kind of rubbish. But as I looked more into it and what the flat earthers were saying and how NASA was always coming up with strange excuses for not having a photo or actual video footage of this globe Earth, and lots of interesting ISS footage like green screen malfunctions or astronauts caught on wires, astronauts fading out, all these weird things that and of course we have never been back to the moon since 1969, I believe, and it's 2020 and we're still, you know, not there. So yeah, so all of these things definitely led me to believe that there's some truth in the flat earthers, and I'm not 100% saying the earth is flat. I don't think any rational flat earther out there would not say that, because no one's actually sent something outside of our the firmament or whatever to actually, you know, photograph Earth. But it does, the globe model no longer convinces me. And but hey, I mean, I'm always open to discuss, and if it can be done in a rational, you know, well-mannered way, I'm always open to new ideas and new evidence, for sure.
So what would you say is the biggest evidence for you that really convinces you that the Earth could be flat?
Yeah, as I mentioned last time I was here, it's the footage. For the footage that I see 20 miles up, it does not seem to be what I expected from NASA. From what my mind is always like, okay, you go like 20 miles up, you should see some actual curvature, and you should see like a globe beneath you at that point. But it's just like it seems the horizon keeps rising to the eye level, which is in a way a phenomenon on its own. And I actually shared a link with you with showing the Florida. Yeah, if you can maybe show that. Yes, so this is an actual ISS image released from NASA, and as you can see, this to me looks extremely odd. Like it looks terribly distorted. I mean, if this was to be taken as the actual curvature, then Florida should be taking up, I don't know, half the planet or something, or whatever it is. And that's another word I wanted to say quickly, like planet. If you remove the T, it becomes plane. It's almost like it's kind of hidden in plain sight if you think about it.
I mean, that's kind of just semantics, but well, this particular photo was taken March 7th, 2019 with a Nikon D5 digital camera using a 20mm lens provided by the ISS Crew Earth Observations Facility and the Earth Science and Remote Sensing Unit, Johnson Space Center. So, I mean, it's taken with a physical camera. Looks like there's some kind of fisheye lens on there to me, honestly.
Yeah. Again, yeah.
Which kind of makes it hard to. I think they wanted the wide-angle shot, and that's what they've got there. But they're not trying to take a photo to prove the curvature of the Earth. They're just trying to take a cool photo, and that's the main thing about images like this, because there is plenty of images that are taken with things that don't have fisheye, and have completely different imaging capabilities, like Discover Satellite and the Himawari, and fisheye and things like that aren't an issue for those kind of cameras. So that's what we can use to accurately determine what the Earth should look like when we take a photo of it. The thing about all the weather balloon footage and stuff, like 120,000 feet or whatever that's still peanuts. That's still not that high up compared to the size of the Earth. It's really not. It's like 60 miles or something, which it is from where I am here down to Newcastle, which is a tiny, tiny, tiny portion of the globe. So to be able to see the actual curvature, most of the time you have to go up even higher than that. But there is a lot of the curvature that you can quite clearly see, a lot of the videos that you can quite clearly see that there is curvature. Like the one that I showed you yesterday from the dog cam, that even as it crosses over the center line, you can tell it's not fisheye, yet it's still curved. And a lot of the images that we get from the weather balloons and that are taken with, I don't know, like 360-degree cameras, which will make things look flat and are kind of subjective things to look at.
Okay, well, Nathan Thompson is actually in the chat. If you don't mind me just reading his comment, it says,
so
120,000 feet up, isn't that high? Up? Wow, 5 years ago, Globeheads thought Red Bull jump was proof. Ha ha ha. Well, that's actually a really great point, because 120,000 feet, I believe it was like a globe. I mean, back then when I was a globehead myself, I thought that was the actual curvature, but
I mean, we know that there was fisheye lenses on a lot of those cameras as well. But I mean, that comment from Nathan's kind of irrelevant, because 5 years ago I never thought I'd have a YouTube channel talking about flat Earth, so that's nothing to do with me. I've never claimed that as proof, so it's a bit of a complete non sequitur from Nathan that doesn't really mean anything. I'm not double speaking in any way, because I've never claimed that the Red Bull jump is evidence that the Earth is a globe. I'm just saying that the Earth is absolutely humongous, and to be able to see the curvature really well, you have to be really, really, really high up. Like Justin Franks has just said here in the chat, 120,000 feet sounds high, but compared to the Earth, it's like 0.5 millimeters off the surface of a basketball. So it's really not that high. I don't know what the exact figure is for you to be able to clearly see the curve of the Earth. Depending on conditions, you can see it when you're in a plane or a Concorde. Lots of people at Concorde, that was a big thing that they said they were up high enough that it made it easier to see the curve of the Earth. It depends on your field of view, obviously. But photographs can be manipulated. You know, everyone knows that. That's something big from your side. If I show you an image like this one that was taken in 1972 with a Hasselblad camera 70mm lens and then developed in a dark room, I mean, the only response I can ever get from flat earthers is that must be fake. And although it was in 1972 before Photoshop and stuff and it was a physical camera, you know, I can't deny straight up that photos can be manipulated. So I prefer to go with things that can physically measure something like the rotation of the Earth.
Yes, that's a good point.
Yeah.
The rotation of the Earth is a great topic in itself. Like it's going at 1,000 miles per hour or something like that, right? The rotation.
Well, no, it's not really.
Oh.
The surface of the equator, so around the middle of that of the ball, is its tangential velocity. So its velocity in a straight line at any one point is about 1,060 miles an hour. Okay, but it still takes 24 hours for the globe to do one rotation. And when we're talking about rotation and forces involved from rotation, we talk about RPM. We don't talk about miles per hour or tangential velocity. We talk about the amount of revolutions per minute that it actually rotates at. And that's what you use to calculate things like centrifugal force. So even though the tangential velocity of the equator is about 1,000 miles an hour, the actual centrifugal acceleration that you're getting from that is about 0.3% of the gravitational acceleration, which would mean that the Earth would have to spin 276 times faster to match the gravitational acceleration. So it's not spinning anywhere near fast enough to like fling you off or anything.
I understand it's not fast enough to fling me off, but say, for example, let's go back to that Red Bull jump. So he jumped at a considerable height, right? So, but I think he jumped over New Mexico and he landed again right there. You would imagine that there would be like a bit of a movement of the rotation so that he would land maybe more towards the ocean or something, like a little bit further away.
Well, but the thing is, when he went up there, he still had the momentum of the rotation. It's called the conservation of momentum. So as he went up in that balloon maintained the rotational velocity that it had when it left. As soon as it left the ground, it didn't all of a sudden, go backwards at 1,000 miles an hour. It keeps that momentum unless there's no force applied. So, and he was barely out of the atmosphere. He's pretty much still in the atmosphere. And the point is, the atmosphere rotates with the globe, and he already has that momentum. So he's gonna keep that momentum, that rotational velocity, even as he's falling. So that you're not really looking at any reason why he would deviate. Once he's in the atmosphere is rotating with the Earth. He's not moving backwards at 1,000 miles an hour. He's moving with the atmosphere, even though he's falling towards the Earth.
So the atmosphere is moving with the Earth. Is there any conclusive experiment that that can prove that, or how does that affect the wind? Like, I know a wind is it like different from the atmosphere?
Right. So what you have to think about things like wind is that's what we would call a macro system, right? But there may be within that system within a storm system, there might be wind moving east and west, north and south, but that entire system of storm is still rotating with the Earth. So you understand, within that within that system of the storm, there is lots of movement, but that entire thing that is the storm is also rotating with the Earth. So the rotation, although the rotation of the Earth can explain a lot of things like hurricanes, and one thing that a flat Earth can't explain is why a hurricane literally dies if it crosses the equator. Why would that happen on a flat Earth? If the flat Earth isn't rotating, why would it, when it crosses that point on the disk, why would a hurricane just die? It happens on the globe because of the counter-rotating hemispheres, and the Coriolis forces literally rip apart the hurricane and stop it. So a hurricane will never cross the equator and survive. It literally just dies when it crosses the equator. And there's no explanation for that on a non-rotating Earth. Now, the thing is, you said, is there any evidence that the atmosphere moves with the Earth? Well, yes, aeroplanes are really good evidence that the atmosphere moves with the Earth, because if the atmosphere didn't move with the Earth, an airplane could just take off and then kind of hover in the air for a little bit and wait for the next location to come around underneath it. It doesn't. An airplane uses the atmosphere to fly, and the atmosphere is rotating with the Earth, which is why there isn't really a significant difference in travel times traveling east to west and west to east, because the atmosphere is rotating with the Earth and planes use the atmosphere to fly.
I find that very fascinating, that the atmosphere, which cannot really be like, I mean, it's air, right? I mean, we just walk through air, we don't really feel its presence at all, really, other than, you know, like, it can be, of course, we breathe in air, and but it's almost like you're saying the atmosphere is kind of attached to the Earth.
Well, the thing is, the atmosphere has been on the Earth for billions of years, and that means there's been billions of years of gravitational force pulling the atmosphere down, and rotational friction forces literally dragging the atmosphere along. So it's had, you know, imagine if you put your finger in a bowl of water and started swirling, right? It would take a while, but eventually that whole bowl of water would be swirling with your finger, because of the friction of each water molecule touching the next one and dragging it along. And eventually the whole thing has a rotational velocity that will be equivalent to the rotation of your finger. It's the same with the Earth. The Earth's been spinning for billions of years. And that means the atmosphere has had billions of years of friction, of dragging it along. And it literally means that there is a column of air right above you, all the way up, that rotates with you. Obviously, like I said, wind can move it north, south, east, west within a relatively macro system. But, you know, on that whole system is also rotating with the Earth.
So gravity, you say, as you say, kind of holds everything together in some
Well, gravity
way.
pulls everything towards the center of the Earth. I mean, one thing you can't deny is that there's an acceleration, right? So I drop this pen and it doesn't just move instantly. It goes from not moving to moving. And that acceleration is approximately 9.8 meters per second squared. So there is an acceleration, not just things fall, there's an acceleration, which means that there must be some kind of force being applied.
Yeah, there is some force, but as you, as any astrophysicist would tell you, gravity is still a theory. It's not, hasn't really been
Well, that's not
proven.
really true. Gravity is what we call a scientific theory, which is very different to the common vernacular usage of the word theory. You know, a theory means like a best guess, but when in science, when we use the word theory, we are meaning something that has been through rigorous testing and has a model built around it and has a body of evidence to show that that is the case. Of course, scientific theories can be updated, but we treat scientific theories as facts. It really doesn't mean the same as just a theory. And also, there is the universal law of gravitational attraction. You know, Newton's G equals m1 m2 over r squared. You know, that's kind of a law that can't be denied. We know that there is a downward force. So you can say that gravity is just a theory as much as you want, but it doesn't change the fact that there is a downward acceleration that everything on Earth experiences.
Oh, for sure. Well, flat earthers, we believe more on buoyancy, like, you know, things with heavier density than air tend to go down. Like that's, and things with lesser density than air, like helium balloons, for example, tend to float up.
But
whereas
why?
gravity seems to like be selective.
No.
Whereas buoyancy
right.
is better, and it's provable in science experiments.
Let me explain what. When we're talking about the atmosphere, we know there's a gradient, right? So there's higher pressure down here with us, and it gets less and less as you go up. Yeah? So what that means is that even on an object like this, the air pressure is slightly higher here than it is up here, meaning there's more density here than there is here. So if the relative motion of things was due to the density of things, when I let go of this, it wouldn't go down, it would go up, because that is the direction where the the less dense medium is. The air is more dense as it gets towards the ground. So why would something choose to travel through the more dense medium if there is a relationship between movement and relative density? The reason it does it is because there is a downward acceleration. Now, buoyancy is another thing. Buoyancy actually requires that downward acceleration. The equation for buoyancy has gravity in it as one of its functions, right? Now, what buoyancy, if this was a helium balloon, it would go up, you're right. But the reason for that is that the air is more dense than the object, which means that there's more mass for gravity to pull down the air. So it will pull down the denser medium more than it will the lighter medium, meaning that that will create an upward force and push it up. And it's a similar thing if you're in a car and you've got a helium balloon in a car, right? If you hit the brakes on a car, what happens to you? You get thrown forward, right? But in a car, if you hit the brakes and you've got a helium balloon, it goes backwards. And that happens for the same reason that a helium balloon goes up in the atmosphere, because the more dense medium of the air is being forced forward more, which creates a force in the opposite direction, pushing that helium balloon towards the back of the car. So buoyancy actually requires a vector, a direction. Something needs to give it a direction for buoyancy to be a thing. And that direction is gravity.
So maybe, I mean, if you can, I mean, tell the scientific community, maybe use something like that to prove gravity and just like end the debate. You know, that's
well, the thing is that there has been lots of things done to demonstrate that there is an attractive force between masses. You know, we can look at the Cavendish experiment or the Schehelian experiment. Both demonstrated that when two masses are in vicinity to each other, they will attract, and the bigger the mass, the more mass there is, the more attractive force it has. Do you know what the Cavendish experiment was?
Yeah, run it by me. Like I would
Right.
like
So
to know more about it.
they had a torsion bar hanging from wire, right? And on the end of this bar, there was a weight on each side. Okay. Now, what they did was they put weights bigger weights close to the ends of the bars. And what they showed was when they moved the weights closer, there was actually, they could calculate the torque on the wire. And it showed that there was an attractive force towards the bigger mass. Because when you moved one mass towards the mass on the end of the bar, it literally made the bar twist, right? And you can measure, you know, the torque coefficient and therefore the force that's being applied. And when they did the Cavendish experiment, it was actually, the aim of it was to weigh the world using the relationship between the attractive force. And if they could figure out how much that was, they could figure out what the Earth weighed based on the force that it was giving us, etc. So what that showed us is that there is an attractive force towards a larger mass. And we call that attractive force gravity. Obviously, the largest mass around us is the Earth below our feet. There is an attractive force towards that larger mass. You have a gravitational field. You have mass. So ever so slightly, you are actually pulling the Earth up towards you. But it's so minuscule compared to the mass of the Earth, you don't really notice that. So, I mean, I think gravity as a function has been proven. There's still a lot of discussion as to the exact reasons why gravity happens. We know that mass warps space-time in such a way that things fall towards it. We don't really know why that happens, but it doesn't change the fact that it does, and we can measure this as an attractive force.
Well, there's a lot of phenomena happening. For instance, another phenomenon that gravity seems to have is the moon is so small it cannot have that much gravity, not enough gravity to have oceans on it, and yet that same moon can affect our oceans through its gravity. So, like, or something like the tidal wave that's how the globe believes.
Let me just get one thing up.
Sure.
Compared to the Earth. Right, so the moon is about 1.2% of Earth's mass, right? And that means that it does have an attractive force of about 1% of what the Earth does. Now, I've actually got a diagram here of tides on a flat, not on a flat Earth, how they work on the globe. Where is it gone? Here we go. Okay, so the way tides work is actually quite simple, right? There is a gravitational attraction from the moon, which would be off to the right of this, okay? Gravity is reliant on two things, the mass of the objects and the distance between the objects, right? And what this means is the water that is on the side that is closest to the moon will have a larger gravitational attraction, so it's pulled more. The water in the middle will have a medium, and then the water on the other side will have a smaller gravitational attraction. But the gravitational attraction is also on the Earth, so it actually pulls the Earth towards it slightly, which leaves a bulge on the other side, which is why you get two tides that act kind of like this, because the Earth is being shifted along with the water and everything ever so slightly, that it leaves a bulge on the side that is opposite of the moon. And that's why we have two tides a day, two high tides, well, 4 tides a day, 2 high tides and 2 low tides. Every point on Earth, even lakes, have high tides and low tides that are, you can figure out where the moon is and see that the moon is literally pulling the water to it. So the moon does have quite a lot of mass compared to the water on the Earth. But at the same time, the moon is in free fall around the Earth and caught in the gravity well of the Earth. So there's a balance of all the forces. And what it results in is 2 tides, 2 high and 2 low every day.
So it's interesting. Nathan Thompson just pointed out the moon pulls the water to it, but Earth doesn't pull moon to it.
Well, the Earth absolutely does pull the moon to it. That's why the moon is in an orbit around the Earth, because the moon is in free fall towards the Earth, right? That's what an orbit is. The moon is literally just falling towards the Earth, but it doesn't hit the Earth because it has a tangential velocity that is high enough that it misses the Earth and keeps falling around it. That's what an orbit is. It's a tangential velocity that stops something hitting something else. So that's, so he's right. The Earth does pull the moon towards it, and that's why the moon is in an orbit around the Earth, because the Earth is pulling the moon towards it. But what you would actually find on this system of the Earth and the moon, the center of it wouldn't be in the center of the Earth, because there is a gravitational attraction of the moon. So the barycenter, what they call it, is actually slightly away from the center of the Earth, and there's a constant tug, pull and tug from the Earth on the moon and the moon on the Earth, and all the forces balance out and give us the orbit and the tides and everything. So no, right. He's absolutely right. Do you know what? Someone just said in the chat. Do you know what I mean when I say tangential?
Yeah.
So like a straight line on a ball, basically. Right. Okay.
Straight line on a ball. Okay.
So
the moon itself is a fascinating subject, because I know. Do you believe that the moon is rotating as well as the Earth?
Yes, the rotational axis around the moon's rotational axis around its own axis is 28 days, which matches its rotation around the Earth. And that's because of the gravitational pull of the Earth on the moon and the moon on the Earth, and it creates what we call tidal forces. So when it wasn't always the case, probably, but over the years, the kind of tug of the moon, the tug of Earth's gravity on the moon has stopped the rotation of the moon and made it match that of the rotation of the Earth. So that's why we only ever see one face. And you actually see that in about 50% of all the moons in the solar system. A lot of them are tidally locked to their planets. I think Mercury's moon is tidally locked, so it's about 1/3 the rotational axis of what it is around Mercury. But yeah, in a lot of Saturn's moons, you see tidal locking. It's just something that happens because of constant tug of gravity.
I find the odds are just staggeringly against, so the Earth and the moon are so perfectly in sync that we cannot even notice the rotation.
Again, you have to imagine that the Earth's been the moon's been orbiting the Earth for billions of years. So those forces have had time to balance out. It's kind of hard to. I need to touch a video on tidal forces, right? Because, right, so as the moon is orbiting the Earth, all right, it's obviously its own rotation as well, okay? But that rotation means that the center of mass of the moon is always shifting. And that meant that the distance between the center of mass of the Earth and the center of mass of the moon was always shifting. And that would literally cause a tug on, say it was rotating away from Earth as it went around, it would cause a tug pulling it back, meaning that the rotation would slow down. And eventually you would get it matching the rotation of the Earth. And it's just a balancing out of the forces over billions of years. And that's why you do see tidal locking in about half of the moons in the solar system.
It's quite fascinating. And I guess you kind of believe that this all came from the Big Bang and it's just sort of coincidental.
I believe that we are a result of a billion consequential actions, you know, and I think that makes us special. I think that's incredible. I think that all those amazing little things have had to happen to create us, and that makes my place in the universe even more special than if I was created by some god in the sky.
Interesting.
I think it's amazing. I mean, you know, even just thinking about my birth, the consequences that had to happen of my parents meeting, them both being fertile, their parents meeting, etc., etc., etc. You know, the amount of consequences that have happened for me to exist kind of says that consequences are a part of the universe.
Yeah, I mean,
So yeah, I think that the Big Bang happened. I think we were formed from the remnants of a supernova of a star that formed another star and the bits around it, and that formed us. And yeah, I don't say believe, because that's the wrong word. I don't have beliefs. I don't have faith. I see the evidence that points towards that, and I reach the most logical conclusion.
All right.
But,
and also, what are your thoughts on the whole solar eclipse, the perfect eclipse? That also seems like an amazing, like the moon and the sun.
well, it doesn't happen
perfectly.
that often, does it?
Oh, it doesn't, but it seems very odd that the moon is so tiny and the sun is so massive. Like the moon is, I think, 1/4 the size of the Earth, and the sun is like, I think, the sun is like 1,000,000 times the size of the Earth. But the odds of them perfectly, you know, like overlapping, and what flat earthers do believe is, and we see it with our own eyes during the eclipse, that the moon and the sun are more or less the same size, and not actually the actual globe model that we grew up with. You know, most of us were indoctrinated with. What are any thoughts on that? Like,
I think it's just another incredible consequence. But it is what it is. The Earth, the sun, and the moon have the relative same apparent size in the sky, and the distance between the Earth and the moon and the Earth and the sun is like exactly 300 times or whatever. But I mean, like I've said, consequences happen, and I don't think there's any reason why that couldn't be a thing. But there is a lot of issues with the sun and the moon being small and local that we don't have if we say the sun and the moon are far away and really big. Because if the sun and the moon were local to us, then we would see them change in their apparent size throughout the day. As the sun moved towards you, it would get bigger, and as it went away from you, it would get smaller. But it doesn't. The sun stays the same apparent size in the sky.
By the way, there's footage of the sun kind of coming in, and like it's small, and then it goes larger, and then it goes.
But the issue with a lot of those footage is they didn't use a solar filter. Now, if you give me 1 sec, I can get a video up to demonstrate this.
Right.
Just give me 1 sec.
Yes. Hello, dear. Yeah. Good. I'm just in the middle of a conversation right now. I'm just online. There's a live debate. Yeah.
Oh God, why can't I find it?
Oh, I understand. Sure, Nikki. Yeah, you can stay over if you want. All right? Yeah. Okay. Love you. Bye. Thank you so much. Take care. Bye. Sorry, that's just my wife calling.
No worries. If someone could send me the link to Red Rhetoric's Zetic Astronomy, I'll just go to his channel, it'll be on there.
So Nathan Thompson, if I can quote him again,
Yeah.
crepuscular rays prove the sun is local. It's the only way we get crepuscular rays. Local
No,
light
because
obstructs.
crepuscular rays change in apparent position when you go past them, which wouldn't happen if the sun was small and local. I've shown that many times.
Oh, I've seen heat spots, like hot spots from
Yeah, that's just
footage.
reflection. It's not a hot spot, it's just a reflection of the light that you would expect to get. I've actually seen that recreated on a real globe with a light that's apparently the size of the sun. Sorry, would you just bear with me for 1 minute while I try and find this.
No worries.
Control F. Oh man, where is it? Sorry guys, just bear with me 1 sec. Checking Gizmo. Ah, there we go. Right. So yeah, we can get to crepuscular rays after, because they actually prove the sun is far away with light rays coming in parallel. Right. Okay, so a friend of mine, Red's Rhetoric, did this video in response to something called Zetic Astronomy, where he recorded the sun throughout the whole day using a solar filter to remove any flare, any glare or anything, right? And what he found was that throughout the entire day, let me get to the bit where he plays them side by side. Throughout the entire day, the sun did not change in apparent size, like at all. And if the sun was small and local, it would change in apparent size by about 5 to 6 times as it came towards you and went away, but it doesn't. Throughout the entire day, the apparent size of the sun, when you remove all glare and everything so you can actually tell, is exactly the same throughout the whole day. And this has been repeated by a lot of other people as well. So how would that be the case? Because the Earth, the sun could not be small and local for that to be the case. There's no reason why the apparent size wouldn't change. Does that not demonstrate that the sun is far away?
Well, I mean, is there any time lapse footage of that? Like, because you kind of just showed me like a slideshow of the sun like going.
I mean, the whole thing has time lapse footage. That's what the whole video is. I just showed you the end.
This camera showing the sun, the solar filter on, just rising and setting with the mountains and water, all that. Actual
possibly. They'd have to track the sun for the whole day, I guess. But I mean, that also requires recording for the whole day, which is a lot of memory. But these are observations that anyone can recreate. If you get a solar filter and track the sun throughout the day, you'll always find the same, that it doesn't change in apparent size, and it's kind of undeniable that is the case.
Again, I would love to see actual video footage rather than just you showing me one photo after another.
Let me just see if I can find one quickly.
Sure. Go ahead.
All right, now I'd have to look, and there possibly is one, but I'd have to look and find it. But it's something that you could do yourself. I mean, solar filters don't cost very much, and I would stake my channel on it that the same outcome would be the case, that the sun does not change in apparent size.
That's a good challenge for anybody out there listening. Put a solar filter on and prove the sun does not change size throughout the sky. I mean, I personally believe it does. But
it really doesn't. There's lots of other videos online that will show the same thing. The only ones that you will see when it appears to change is when there isn't a solar filter attached, or if you're watching the Flat Earth Brothers, who are liars, because the Flat Earth Brothers tried to do the same thing, but they then manipulated the photos. I actually looked into it, and they changed the pixel sizes on some of the pictures to make it appear smaller. So, yeah, apart from theirs, all the others will show you that the sun does not change in apparent size. And that's kind of a killer for the flat Earth, isn't it?
Not really. I mean, we still have a lot of footage that show that the sun does change in size, but I mean, I'm still waiting for that
only
one
without solar filters. They're important things.
Okay. I understand that. Yeah, if you could produce that video footage with the solar footage,
or a flat earther could, like Nathan Thompson's going on about. He's got lots of footage, but he didn't use a solar filter, and he knows that. But that's because he doesn't eat enough meat and doesn't have any protein, and his brain's probably not working properly. Yes, I've seen the videos, Nathan, and I've debunked them. You didn't use a solar filter, you penis. Honestly, Nathan Thompson is someone you do not want to listen to, because he is, there's wrong, and then there's Nathan Thompson. Plus, he's a horrific human being that is not someone that you should look up to in any kind of way.
That's pretty. I find that a bit harsh, but okay.
No, it's absolutely true. He is a horrific, horrible human being. That they're just someone. Negative exponents. If you're watching, send Sonny the videos of Nathan that prove what a nice person he is, because he's done some horrible things. But anyway,
well, he doesn't. He's vegan, so he doesn't hurt animals. I guess that's one good thing.
I mean, ask his dog doesn't get fed, but
I'm not a vegan, by the way. I eat meat.
Yeah, so do I. Although I do think everybody should reduce their meat consumption for environmental reasons.
Oh, yeah.
We've gone veg like 2-3 times a week in the family, so it's.
Oh yeah. Just a balanced diet.
Yeah. Right, but if the sun didn't change in apparent size, that's an issue, right?
Pardon? The sun didn't change?
Yeah, if the sun doesn't change in apparent size, then that is an issue for the flat Earth, or at least for the notion of the sun being small and local.
It would be an issue. I mean, the sun. It's kind of like the perspective, so it's kind of coming. I mean, the globe Earth we believe that I used to believe the sun was rising, but in fact, the sun is kind of like coming in and out. And so, yes, it would have to be small and then come large and then go back.
And not just a little bit either. Like, it would have to be a big difference. Like, a 6-time difference probably between sunrise and midday. But
there's plenty of footage of it. But for some reason, I guess because there's no solar filter, I don't know.
And solar filters, the idea of a solar filter is it removes like 99% of the light. So you don't get all the glare effects. Because, with glare, the apparent size can definitely change. But that's not really conclusive.
The glare is going to increase, of course. I mean, as the sun comes closer, the glare is obviously going to increase. So, and because the sun is larger in the sky, there's going to be more glare. And when it goes back or whatever, it's smaller.
Yeah,
so
but that's why you need to remove things like the glare and apply what we call controls. Because if you remove the glare, you can get a true image of what the apparent size of the sun is. And the result is that it doesn't change in angular size at all, unless you don't have a solar filter on, Nathan Thompson. You can keep saying it all you like, but you didn't have a solar filter on. Right, so... Sonny, why don't you I'd love you to do that yourself. I'm sure you've got a camera. Grab a solar filter off Amazon and do it yourself, because if you see it for yourself, then there's no one that you can deny it to, right?
I see it from myself, my eyes, every day.
Yeah, but your eyes don't have solar filters on.
But okay, I mean, that's your argument, but I like, to be honest, I don't think it debunks the local sun. Just a solar filter would not debunk a local sun.
Well, it's not that a solar filter debunks it. It's that the fact it doesn't change in apparent size when you have a solar filter on is what debunks a small local sun. Because it would have to change in apparent size. And when you apply the correct controls so that you can actually see the brightest thing in the sky, then you see that it doesn't change in apparent size. I mean, it's also something that you can see quite clearly on eclipses and stuff, because the apparent size wouldn't always be the same when there's eclipses and stuff. So, why don't we move on from that right now? Because I would love for you to do
Okay.
it yourself. Get yourself a solar filter and take pictures of the sun throughout the day and just prove it to yourself. Now, you said Eric Dubay had convinced you of some things. What's Eric Dubay done to your brain?
I mean, a lot of he has like 200 proofs. Obviously, we can't go over all of them, but one of them would be maybe the lighthouse that I find fascinating.
What's the
Lighthouse
issue
has
with
been used.
lighthouses?
Well, I mean, the Earth, I mean, has the curvature would block the ship from being able to see the lighthouse. I mean, according to your own calculations. So,
Okay.
but a lighthouse can still see miles and miles away. Now, I
So-
understand you're telling. Yeah, go ahead.
Yeah,
Sorry.
lighthouses are equipped with powerful lights. In a dark night, even the entire structure is obscured by Earth's curvature. The phenomenon of the loom of the light allows their lights to be visible beyond the horizon, not unlike how the beam of a green laser is visible to our eyes. Flat earthers like to point out when the cases where the light from a lighthouse is visible even if it shouldn't be completely obscured by Earth's curvature, claiming it proves Earth is flat. They're wrong. The loom of the light lets us see the light even when the lighthouse itself is below the horizon. I was a sailor in the Royal Navy for many years.
Oh, wow.
I've seen a lot of lighthouses, and I have seen the light before the actual lighthouses, and that's how they're designed. They have to be designed that way so that ships can see them. Because the geometric horizon is generally only about 3 miles away, so there could be rocks a lot further out than that. So ships need to be able to see them. So that they were designed with this in mind, that they would be able to be seen past the curve of the Earth. It's just how light works.
That's loom of the light. Well, I'm learning. That's a new. That's a pretty new phrase. I've never heard of that one. Loom of the light. Same way, I never really heard about refraction until people were using their Nikon P cameras to bring the ship back into the where it was supposed to be the curve. So it seems there's newer terms being invented as people are.
Well, this has been around
questioning
for a
the-
long time, like since lighthouses have been around.
Yeah, but it's interesting what you're bringing up. It's an interesting theory.
Yeah,
Loom of the light.
Yeah, it's just how lighthouses work. Because yes, of course, there's a lot of cases where you shouldn't be able to see the lighthouse, but you can still see the light. I mean, what you got to remember is there's usually clouds and stuff over sea, especially fog or whatever, and that's going to make this loomed light even more visible.
Mm-hmm. That's quite interesting. So like it's like every time there's something that we can observe, we provide some observable evidence. It's something that seems to be added in. Like okay, the sun. We can see the sun is growing from small to large. You added the word solar filter in there, and then now when I bring up the lighthouse, you're adding because of the loom of the light phenomenon. So
Yeah,
it's interesting.
It's just how physics works. I mean, the phenomenon of light glare isn't an unknown thing. Of course, the sun is the brightest thing in the sky. It looks like it's glaring, so we need to remove that glare to actually be able to see it properly. Does that make sense?
Yeah.
I mean,
I'm just, yeah.
a solar filter doesn't change the shape of it in any way. All it does is remove about 99% of the light. And lighthouse looming is literally how they were designed with that in mind, so that you could see it from miles out at sea.
So even back then, they had an idea about the curvature, and that's why
They've had a fair idea for a couple of thousand years, yeah.
Okay, I mean, that's how the curvature was deemed as, right? Because they could see the ships go back, over the curve.
That
It's
was
one of the first-
a very early observation, yeah. The ships appeared to disappear bottom first, and I can confirm that is the case. I've watched them with high-power binoculars from the bridge of HMS Westminster disappear below the horizon bottom first. But I've also seen them on days where refractive conditions were such that the angular size got too small before I could see it disappear bottom first. I'm sure if I had more powerful binoculars than were available, I could have zoomed in more and seen it actually go over the horizon. But generally you do see things disappear bottom up. So yeah, and
you. Right, go ahead.
sorry, go on.
Oh no, you've seen footage of people bringing the ship back that was supposedly over the curve, and with their, and you've seen footage of that.
Yeah, and I've got a video that can debunk that real quick. Let me grab that. I should keep that available, actually. So another friend of mine who's called Dazza the Cameraman.
Mm-hmm.
Here we go. He came across the claim of zooming things back in makes them, come back over the horizon. So he decided to test that himself.
Okay.
Okay, here we go.
Saturday, February 9th, 2019.
So, is this the right one? Oh crap, I think I got the wrong one.
Oh.
Yeah, I did. I got the wrong one, sorry. I'll get rid of that. Right. Sorry, one sec. Web browser.
Yeah, no worries. Take your time.
It doesn't take too long to program the things in, luckily. Right, so here we go. Using his Nikon P1000.
Clear, effective writing that drives the
Ignore the
results you
advert.
want.
Nice.
Okay, so I'll zoom it, I'll speed up a bit as well.
Mm-hmm.
So we test the flat Earth myth that more zoom will cause ships to come back above the horizon. Does the proportion of the ship visible above the horizon versus that which is hidden change as we use more optical zoom? He used a Nikon P1000 camera with 125 times optical zoom to test this claim. The distant sinking ship, Princess Paula, was 12.6 miles. The closer ship, the glorious Mahatta, was at 8.86 miles. The camera was approximately 30 feet off the water. And what he did was, as he zoomed in a bit, he took a screenshot, right? So he goes back in, he looks at this ship and then the one behind it, and he takes a screenshot of the one that's slightly over the horizon. And then he continues to zoom in all the way to the maximum 125 times optical zoom of the P1000. And what you found is that the proportion of the ship visible when zoomed in actually matches exactly the proportion of the ship when zoomed out, showing that zooming in on something over the horizon in no way brings it back above the horizon. What you're referring to is a phenomenon called, this is all down to the Rayleigh criteria and diffraction. Flat earthers misuse this all the time. What that means is those ships were really big, right? Really big. But when you've got little sailboats that go into the distance, the angular size becomes so small that your eyes can't resolve it anymore. So what you do then is you get out a camera with a zoom and you zoom in, and it appears to bring it back from not being visible. But all that's done is it's zoomed in and changed the angular size, meaning that you can now see that object because you've zoomed in. If you zoom all the way out again, it disappears because the angular size is so small that the aperture of the camera can't actually pick up the light that's coming from it. There's not enough pixels on the screen of the camera to display it. But as you zoom back in and it increases the angular size, you can then see it again. But that's only with objects that are small, which is why we test this claim with bigger ships like Dazza did here, and it shows pretty conclusively that zooming something in does not bring it back above the horizon. Also, this was a day where there appeared to be minimal refractive conditions.
Mm-hmm. And well, okay, that's a good video that you showed me, but I'm still not fully convinced because there is also footage of, I'm sure you've heard the famous one with the Chicago skyline that was over 40 miles away, and
yeah,
I mean that.
All right, well, my question to you is, why can't we see that skyline all of the time?
Well, it's of course the atmospheric conditions and those kind of things, right? But that being said, at that distance, the Chicago skyline should have been like over 1,000 feet below the horizon that you say where this curvature is. So that was a very big revealing moment for sure.
Right.
And
so
of course you come up with like a superior mirage or something like that.
Well, I can show you evidence of that being the case. That as the thing is, over the Chicago, over that lake, the water is really cold and the air is going to be about freezing. All right, so the air is more dense, which means that it's going to refract the light more and bring what's behind the horizon up. And I can demonstrate that that actually does happen. Just give me 1 sec to bring this video in. So this is a video from a channel called Danjos. And what he does is he's put these plasticine layers on this can, right? So you can see the yellow one at the bottom, the red one in the middle, and the green at the top. Okay? And what he does is he puts this behind a curved surface, that tank that you see there. You get the camera set up and you'll be able to see it.
Okay. I like this, a mini experiment.
Yeah. Right. So what you can see there is the green, the top of that, okay? And below that there is a yellow and a red band, right? We've just saw that and we know that's behind there, okay? Now we can't see what's behind there at the moment because there isn't much refraction. So what he uses is he uses liquid butane, I believe, which has a temperature of about 0 degrees centigrade, and that simulates the refractive conditions along the Chicago skyline. So what he does is he pours the butane onto that tank, increasing the refractive index, increasing the lapse rate, and therefore the coefficient of refraction. And when he does that, what you see is that you can see more of the colors that are on that. Come on, get on with it. Now you see that, how it brought that red up that wasn't there before? Okay, we know that that red color is behind the curve of this tank, right? But we've just seen it. And the reason it's done that is because the light has refracted more. The light has bent down and brought the red image back up above.
Okay, so sorry, it was green, yellow, and then red, right?
Yeah, green, red, and then yellow, I think. Let me go back to see it. Yeah, green, red, and yellow.
So it's kind of like upside down. Yeah, there is a phenomenon called superior image. That's
what we call looming, right? And what this demonstrates is that Chicago skyline photo is perfectly possible if the refractive conditions are correct. And how it was 60 miles, right?
Yeah, actually 40 miles, I believe.
Right. Well, at 40 miles, light would have to bend. I'm just doing some quick math in my head. Bear with me.
Actually, 52 miles away.
52 miles, right? Let's go with 60 then, right? Well, if it's 60 miles, light would have to bend 0.162 degrees, right? 0.162 degrees. That's nothing. Standard refractive conditions are 0.5. So again, it kind of matches what we predict would happen with a refractive index. And we know that the air is colder and denser closer to the water. And therefore, we can deduce that the light is being refracted. And like I said, for 60 miles, 0.162%, the light would have to bend. And standard refraction is like 4 times that, It is 0.5.
Okay. Well, first off, I love those, like I mentioned in our last debate, I love those micro experiments that can prove the macro. Because if you can do it in a micro setting, then that's really, really, it's repeatable and it's easier to deduce. Now, the Chicago skyline, unfortunately, doesn't quite look like what you just demonstrated in that micro experiment, the smaller experiment with the gas cylinder, because it looks much more, for one, it's much more consistent. As you can, it's...
Obviously, that's over a much larger distance, and the point of the video that I showed you is that you can, in fact, bring things that are hidden behind back up above the horizon. And there is a lot of times where we will see compression of buildings and stuff with refraction. Refraction can do all kinds of crazy things and make things look inverted and wobbly and stuff. But the refractive conditions on the Chicago skyline were just about right, that it looked about right. But if you actually look at that skyline picture and compare it with the actual Chicago skyline, you find a lot of the buildings are very distorted. But again,
well, at that
right,
distance,
if the Earth is flat, the question is, where's the bottom of those buildings and the shoreline in front of it? Shouldn't we be able to see it?
If you zoomed further, I'm pretty sure you would see the bottom. Like, it's just
Well,
like I said,
I just showed you that zooming in doesn't bring things back. So
yeah.
So zooming in on the Chicago skyline wouldn't allow you to see more of it, because that's zooming in. All zooming in does is it increases the angular size of something. It can't see further. It just makes what is there bigger. It's like putting a big magnifying glass in front of it. It's not going to bring something back. It just makes it bigger.
Mm-hmm. Well, that's fascinating. I'm looking at both sides here, and
as long as you got an open mind, that's all I ask.
oh yeah. Same with you. As long as you're open to the flat Earth phenomenon, you can tell there is a lot of things going for both. I mean, of course you're still on the globe side, but
yeah. The thing is, like I've said, I don't have beliefs. The reason that I say that the Earth's a globe is because demonstrable evidence shows that to be the case, and it's the most logical position to hold. I honestly think it's complete fantasy and silly to think that the Earth could be flat. Physics just doesn't work that way. Gravity doesn't work that way. If the sun and the moon are small and local, what's powering them? How are they just floating up above us? What's going on? There's so many things that the flat Earth can't explain in the slightest that are perfectly explained by the heliocentric model. The thing about the heliocentric model is it doesn't have any issues at all. The only issues that flat earthers find is their misunderstanding of physics around it. And I'm not trying to be condescending. I've got a bachelor's degree in physics. I studied physics. I wanted to understand how the universe worked and why things did what they did. So I can look at the evidence and make deductions based on my knowledge that show that the Earth is a globe. I don't think any flat earther has a degree in physics. Like, I would honestly, I'd bet money on the fact that no flat earther has a bachelor's of science in physics, because if they did, they could not be a flat earther, because physics doesn't work that way. And it's not indoctrination, because to get my degree, I had to practically demonstrate what I knew to be the case. You have to do experiments and show that the maths and stuff that you're learning can be practically applied to the real world, and it does.
Right. But do you think somebody that genuinely believes in the flat Earth would be given a degree in physics?
If they passed, then yes. If they genuinely believed, but they also were able to pass the physics degree and practically demonstrate their knowledge, then yes, they'd get the degree. But that's the thing. Whilst they were practically demonstrating their knowledge, they could no longer be a flat earther, because the two things don't mesh. You can't go and do all that studying and practically demonstrate your knowledge to show that the maths and stuff that you've been learning is correct, and then still think the Earth is flat. Those two things are incompatible.
I mean, it could, like you said, that how does the sun and the moon float without gravity? It could be like I'm sure you've heard of the electromagnetic universe kind of theory.
And there's many problems with that.
But it could be one of the explanations. It doesn't have to be this gravity thing that's holding everything together. It could be just that there's Earth has its own magnetic pole, and it's
Earth does have a magnetic field, and we can use what's it called? There's an equation that's very similar to Newton's law of gravitational attraction, and I forget the name of it for a second, but it's about electromagnetic attraction, right? Let me get the name because it's going to bug me otherwise. Anyway, I'll remember the name. But anyway, you can use the law of the mathematical formula to figure out electrostatic charge between things and everything. But the issue with saying that it's electromagnetism or electrostatics is that everything has a different electrical potential. This pen and this phone are made of different materials, and those different materials have different electrostatic potential. They have different charges. They're affected by electromagnetism in different ways. But they also both accelerate towards the ground if I let go at them at exactly the same 9.8 meters per second squared. If the acceleration towards the ground was due to electrostatics or electromagnetism, things would accelerate at different rates based on their material composition. Most metals are a lot more conducive to electric currents and electromagnetism, and would be attracted to the Earth more. Things that are strongly diamagnetic would float. Yeah, but we don't see that happening. Also, if I was to stand in a Faraday cage, which blocks out electromagnetic radiation, I would float, and I don't. I've been in a Faraday cage.
Okay.
So no, I'm looking into a lot more about electric universe. That is Coulomb's law. Thank you very much. Electrostatics. That's it. Robert Ad said Coulomb's law for electrostatics. That's what I was talking about. It's very similar to Newton's law of gravitational attraction, but it requires knowing the material composition and their electrical potential and everything, and it would be different for different materials, and we don't experience that. Everything has the same acceleration towards the ground, which can only be explained if there is an equal force acting on everything.
That's but a helium balloon can prove that very wrong very quickly.
Well, we talked about buoyancy earlier, didn't we? There's a reason that goes up, because it's got less mass, less density than the air, which means the air gets pulled down more than the helium balloon, which causes the force in the opposite direction. Buoyancy, part of the formula for buoyancy has G for gravity in it. You literally can't have buoyancy without gravity. And if we're, why does something fall in a vacuum chamber still towards the ground? Because there's no medium. There's no, density difference. Well, I suppose there is. There's no density. So shouldn't it fall a lot faster in a vacuum chamber? It doesn't. It still has an acceleration of 9.8 meters per second squared, which kind of disproves the whole density buoyancy thing.
Oh, you mean the throwing items in a vacuum, right? The feather and the bowling ball?
Yeah.
That whole...
They still both accelerate towards the ground at 9.8 meters per second squared, yet they've both got very different densities.
Interesting. I think that one has been debunked, but there was a YouTube video.
Definitely hasn't. I can show you lots more experiments than that one that was done by BBC that was heavily edited. There's a channel called Science Lab who's got his own little vacuum chamber, and he's showed things inside that falling the whole length exactly the same rate, a feather and a penny, I think it was. So no matter the object and no matter the conditions, everything accelerates at the same. Of course, there's air resistance. I drop a bit of paper, it's going to float. That's because the air can cause resistance on the surface area based over its mass. But buoyancy and density can't explain these things.
And and I'm sure you've seen all those footage of. I just wanted to get back to that rotation thing. You've seen those lovely footage, or I think it's filmed underwater, to be honest, but of the astronauts working on their little whatever it is in their station, and the Earth appears to be, it said that the ISS or whatever is moving at 17,000 miles per hour or something.
17,000 kilometers an hour, yeah.
Yeah, and the Earth is moving at 1,000 miles per hour, and yet everything just seems to be very still. Is it? What do you? I mean, what's
it? It takes about 90 minutes for the ISS to orbit the Earth. If you watch a stream for 90 minutes, you see the entire Earth. But 90 minutes is still quite a long. If I was to spend an hour and a half turning this ball, it would still look pretty still to you, right?
Yeah, I understand, but it doesn't look like anything is moving at that speed at all, based on just plain observation.
I mean, there's experimental evidence to show that it is. Again, my friend Reg Rhetoric, him and another guy called Astronomy Live used parallax measurements of the ISS transiting the moon. So they placed themselves a kilometer apart, right? And they knew that at this particular time, the ISS was going to transit the moon. So they made themselves 1 kilometer apart and both filmed the ISS transiting the moon. And then when they took the data of their observations and the parallax that would induce based on the angular size of the moon, they were able to calculate with some basic trigonometry the size of the ISS, the speed of the ISS, the altitude of the ISS, and they got exactly what NASA tell us with no help from NASA at all. Just using empirical observation, they were able to do the calculations and figure out that the ISS is moving the speed that we are told, is the size it is, and is the altitude that we are told, with no help from anyone else. It just happened to match NASA's numbers.
It's just that when we observe it, it all seems to look very still. But
Like said,
when you see a
90
car,
minutes.
you feel that. I mean, when you see a car just going even 100 miles per hour, you can see that it's moving.
Yeah,
I mean,
but if you were 100 miles away from that car, how fast would it look like it was going then?
100 miles away from the car?
Yeah, if you were 100 miles away from the car that was traveling at 100 miles an hour, how fast would it look like that car was moving? It would look like it was going, you wouldn't be able to really tell that it was moving that fast. Because the further you are away from something, the slower distances appear relative to you. And the thing about the ISS is it's a couple of 100 miles up. That's like, it's a long way. So the distances make things look like it's not moving very fast. But if you actually do the observation of the ISS transiting the moon, which anyone can do, you can calculate these things for yourselves. And like I said, how did Red Rhetoric and Astronomy Live come up with these same numbers of NASA based just on their observations?
Also I can see a plane, like how far is the plane away from Earth?
Like 30,000 feet of cruising altitude?
You can see it move pretty,
Yeah,
you can observe.
That's not 100, that's not 200 odd miles though, is it? That's 30,000
No,
feet.
but
I mean, and the airplanes you usually see around airports now aren't usually at cruising altitude. They're probably a lot lower than that. But, all right, think about this. If you see the airplane going over you and it'd take, 20 minutes to go across the sky? What if you were right underneath that airplane? How fast would it look like it was going then?
I would still see the motion for sure.
Yeah, but if you were a lot closer to it, you would see it faster, right? It would zoom past you.
Yeah.
Well, but when you're further away, it looks like it takes longer to travel that distance because you're further away.
So that's what you're thinking. That's what you're saying is happening with the Earth and Astronaut.
Yeah, the ISS is 200 plus miles above. So, and it takes 90 minutes to orbit the Earth. So if it takes an hour and a half of looking at the Earth to go all around, it's not going to look like things are moving very fast.
Interesting.
I mean, just how angular size and speed works, really. I mean, you can't deny that if something is closer to you, it looks like it's going faster than if it's further away from you. It's just how
I just find it
works.
quite interesting, quite odd, but it is what it is. And I'm sure you've seen some footage of space bubbles.
There's a thing that happens when water goes to a gas. I've bloody forgotten the word.
Yeah. Seems I like to have an explanation for everything.
Well, it's because of physics.
Yeah.
I've lost the word. Sublimation. There we go. That's it. Yeah, sublimation. Right. Sublimation happens when a liquid goes to a gas really quickly, or the change of state of matter happens really quickly. When sublimation happens, it expels energy in all directions and goes about. And when you see bubbles in space, all you're seeing is sublimation of water particles or whatever that are ice particles on the outside of the ISS that are, evaporating really quickly and stuff. It's just what happens in those conditions because they're in the vacuum of space. The thing about the bubbles in space, if you're trying to say that they are in a pool, then why do the bubbles go sideways and stuff instead of up? Also, they're not in a pool, and this is not one that many people know about, right? But if you get a picture of an astronaut in water with their suit on, then their head looks smaller.
I'd like to see that if possible.
I'm trying to find.
Sure.
Oh, I can never find images when I need them. Ah, there we go. That's a good. There we go. That's a good one.
So I just wanted to add one point. I have a friend, Ramakrishnan. He's also a fellow flat earther.
Yeah.
He did want to add. He just messaged me. He said the ISS outside is 200 degrees and there's no pressure. Water can't exist in liquid or solid state on it.
That's why it. That's why it sublimates.
How can sublimation happen? And he says it's ridiculous. And ISS looks like a floating image, more like a hologram image. I mean, this is just our opinion. And
okay, right.
So yeah.
If an astronaut was in water, in the helmet, refractive conditions in the water and with the helmet mix and make their head look smaller than it should. I mean, that's not what astronauts look like when they're in their. If I get a proper image and compare it. So, in that image that I'm showing you, an astronaut's underwater with his helmet and his head looks really small because of refraction. But there's a normal outside of the water shot where the head looks normal. So we would know that the astronauts were in water because their heads would be small.
I don't think the head looking smaller means anything because actually a lot of the shots
what it demonstrates is that they're in water. I mean, so we'd know if the astronauts were in water when they're in space because the heads of the astronauts would look a lot smaller.
Yeah.
But yeah, no, sublimation happens. Ice can build up on the outside of the ISS and then, sublimate into space. It's a well-known phenomenon.
I just find it very interesting because water can't exist in any form of liquid in space, obviously. I mean, according to your own theory, but sublimation can somehow happen.
Well, yeah, sublimation happens because it can't exist there. That's the point. It can't exist there, so it's changing its state of matter really quickly.
Okay. Of course, I do know that it's been revealed that they do a lot of their training underwater.
Well, of course they do.
And yeah,
it's the best way to simulate low gravity environments on Earth.
Mm-hmm.
So, of course, it makes sense that they would train in an environment close as possible to the environment they're going to. Why wouldn't they? They know how physics works. And like I said, if a flat earther got a degree in physics, they wouldn't be a flat earther anymore.
Mm-hmm.
So
interesting.
And it's the thing, these aren't excuses, these are just how physics works. These aren't things that people have just come up with in recent years. Physics has always been this way. It's just in the conversation between Flat Earth and Globe Earth, the Globe Earthers have learned more and more how to counter the things that Flat Earthers come up with by understanding basic physics. So, it's not like there's excuses. These are just reasons that we have gone and figured out so that we can explain it to you guys.
I do appreciate the explanation, yeah.
The chat is asking me to do what I call the Flat Earth litmus test.
Okay.
So if you don't mind, I'm going to ask you 3 questions. All right?
Okay.
I have a triangle of sides 1, 1, and 1. What are the internal angles?
No idea.
So that's a fail then, really. It's an equilateral triangle. There's 180 degrees in the triangle. Does that help?
Oh, right. Yes. Sorry, I'm very poor at this stuff.
Okay. Right. So we're gonna say that one's a fail. Right. So what is 5 divided by 0?
5 divided by 0?
Yeah.
This is 5.
Oh, Sonny, no.
Sorry, what?
5 divided by 0 doesn't exist.
0.
You can't
Doesn't
divide.
exist.
You can't divide something by 0. You get an answer that's undefined.
I would do it this though.
Yeah, but that's not the question that division is asking. The question division is asking is how many groups can you separate this into? So you can't separate 5 into 0 groups. So the answer is there isn't an answer.
Well, that's kind of like a trick question, though.
No, it's not a trick question. It's a basic question around mathematics. All right, there's one more. If I said to you the number 10 to the negative 17, is that number a negative or a positive number?
10 to the negative 17?
Yeah.
It would be a negative number.
No, it's a very, very, very small positive number.
Oh, really?
0.000000000000000000001.
Okay.
Okay. Right. There you go, guys. You've had the sharpshooter questions. The thing is, Sonny, and I'm not trying to be condescending, you obviously have a very poor knowledge of physics and mathematics. And honestly, I think if you were to learn a lot of the physics around the questions that you ask, you could kind of figure out the answers yourselves, because you don't seem like a stupid guy. I mean, I've watched your videos. Your brain must work in amazing ways because you're incredibly talented. Especially as an artist and a musician. You know, I've genuinely got one of your songs stuck in my head and it's going to be there for weeks. So you're a smart guy. And I don't think it would be too beyond the scope to say, go and do a college level physics course. You know, you can do it distance learning.
I have no idea what this has to do with the actual debate, and it seems kind of like
The reason I say it is because if you had that knowledge of physics, then you would understand that the Earth cannot be flat. Let's talk about some of the evidence that shows you that the Earth isn't flat. Okay.
Okay.
Do you know what a fiber optic gyroscope is?
Yeah, I've heard of it.
Right.
Okay, gyroscope,
I'm going to play you a short video. Hashtag thanks, Bob. So this is just a 45 seconds. Just watch this for a second for me.
If the Earth is spinning at one rotation every 24 hours, that means that every hour it has to turn 15 degrees. And if the gyroscope is mounted anywhere on Earth, it's going to drift. In today's 21st century navigation systems, they're using what's called a ring laser gyroscope. It is extremely precise. If we could simply get one of these ring laser gyroscopes, we would be able to prove once and for all that there is no rotation to the Earth. One of the people in the community actually purchased one for $20,000. But what we found is when we turned on that gyroscope, we found that we were picking up a drift. A 15 degree per hour drift.
Now, that's impossible if the Earth is flat and non-rotating. Literally impossible. I'm going to try and teach you a basic bit of physics around light for 1 second and how a fiber optic or ring laser gyroscope functions. So there's something called the Sagnac effect, which is all based around the speed of light. Right? And that's how these gyroscopes operate. Okay? If we know the speed of light in a vacuum is a constant, which we do, then we can do calculations based on that. Okay? So, inside of a interferometric ring laser gyroscope, you have... There we go. Right. Oh, wait. Okay, so if you look at the screen here, Sonny.
Yeah, just
right.
1 second. Sorry about that. Just
That's okay.
applying my...
Right, so that gyroscope that Bob was talking about, this is how it works, okay? That blue box fires a beam of light. The diagonal white line is a half silver coated mirror which splits the beam into 2 paths, right? Now we know the speed of light in a vacuum is constant, so when the light hits those 2 paths, it should come back and recombine at the same time. And that's exactly what happens if the gyroscope isn't moving. As you can see, these 2 beams of light go round at the same speed, and then when they get back to the mirror, they recombine, and you wouldn't notice anything. But if the gyroscope itself is rotating, what this does is physically change the distance that one of the paths of light has to travel. And what this means is that when the light recombines at the other side of the mirror, you can measure an interference pattern in the wavelengths of light. Okay? As you can see here, they arrive out of sync, so you would measure that as an interference pattern. And you only get this if the gyroscope is rotating. And that's what Bob was talking about when he said his 15 degree per hour drift. That was the interference pattern that they were seeing. Now, an interferometric fiber optic gyroscope or ring laser gyroscope can't pick up the measurements of the sky because it can't see the sky. It doesn't know what's going on in the sky. It can't be affected by any electromagnetics because light doesn't have a charge and therefore is not affected by electromagnetism. So there is only one explanation for what is happening in that example, and that is that the gyroscope is physically on something that is rotating. And what we find is when you fire up an interferometric fiber optic gyroscope, you instantly start measuring that drift of 15 degrees in 3 axes. 3 axes is only possible on a sphere. But not only do you measure that drift of 15 degrees per hour in 3 axes, you also measure a drift of 1 degree a day on a 2D plane, which is representative of the Earth's orbit around the Sun. Why would that pick up those movements if the Earth was flat and non-rotating?
That's a good one.
It's a killer as far as I'm concerned. It's impossible for this, and every single modern airplane has 3 of these things. One to measure pitch, one to measure yaw, one to measure roll. And they wouldn't work if they couldn't base themselves on the reference of the Earth rotating. That's kind of how they know what the airplane is doing. So there is no explanation for that phenomenon on the flat Earth, like at all. Nathan Thompson and Bob Nadell tried to claim that it was picking up the rotation of the heavens, some kind of heavenly energy, but as I said, light has no charge, which means it's not affected by electromagnetism. So there's nothing else. There is no other explanation. We've eliminated that it can see the sky. We've eliminated that it's being affected by electromagnetic radiation. There is no other option as to why the Sagnac effect inside these things measures that rotation, other than the Earth is rotating at 15 degrees per hour.
So that's your conclusive evidence for
That's my. I call that one of my strongest evidence, because there is no explanation for it outside of a rotating globe. Like, none at all.
So I find it quite fascinating that that's the experiment that you prove on a macro scale what's happening.
Yeah.
Like the actual rotation. Okay.
Yeah. I mean, they base themselves on the fact that there is no absolute reference frame. You know, I suppose they hold their reference to distant stars of the universe. So they can detect motion, well, changes in motion based on what they're on. And there is no answer for it. Could you think of any reason why it would detect that rotation? Not just a rotation like that, but a rotation in 3 axes, which indicates a sphere.
Mm-hmm.
Do you not think that's pretty conclusive?
I mean, I'm not totally convinced, but there's evidence on both sides. That's what I'm seeing more and more of, for sure.
But that's the thing. Any evidence on the flat Earth side is based on a misunderstanding of physics.
No, it's most of the observations on the flat Earth are. I mean, it's just pure observational.
Oh,
for
yeah,
instance,
but we know refraction's a thing close to water, don't we?
Eyes don't lie. Obvious.
Sorry?
I mean, that like what I said. The eyes don't lie.
Well, they
So
do.
what you see- Not really. No.
Yeah,
I mean,
can you see infrared or ultraviolet? Can you see things
No, of
that
course
are
not.
really far away when the angular size gets too small? Thing is,
There are
Sonny,
stations-
our senses are pretty shite. They're really not very good. And that's why we develop
Yet they-
tools to do these things for us.
You can talk to somebody. You can. There's a lot of. I mean, every time we observe something, you kind of like throw in an explanation
Yeah,
or some
because physics
pure
has an
experiment.
explanation.
And I just find it very odd. I mean,
But that's the
try
thing,
to
isn't it? That's the thing, isn't it? Because
Yeah.
there is an explanation. Everything that you guys bring up, we have an explanation because there is an explanation. We're not just making these things up on the fly. We're not just randomly adding them to the heliocentric model. These are things that are demonstrable facts that explain the questions that you guys have. And the Glober flat Earth argument has been going on for a few years, and more us on the Globe side have learnt your questions. So we have learnt how to answer them with physics and actual maths and explanations. So yes, it does seem like you guys will come up with an observation and then a little later we'll have an explanation. Because we see your observation, we go away and think about it, do some physics and maths, and then bring you back an explanation. It's not adding things, it's not magic, it's just there is an explanation to your questions. There is answers, there is reasons why these things happen.
Yeah, it's like, it seems more and more like explanation without proof or some kind of obscure proof.
Haven't I shown you a bunch of like proof today?
Yeah, you have shown me some things, but I'm still not quite convinced. That's what I'm trying to say, because I see the basic observations are not matching up with your, it's not aligning with what you're saying.
But they do. What observation doesn't match what I'm saying?
Like, well, like for example, the very simple observation, you can see the sun is going from small to large in the sky, and you just throw one word, solar filter, and
well, that's not one word. It's two words, and it's a thing that exists. I mean, I'm not making up solar filters. Solar filters were designed to be able to do things like look at the sun.
Obviously, the solar rays are going to be more as the sun gets bigger in the sky, so that shouldn't even be taken into account. It's obvious that the sun is larger.
But it's not larger. When you remove the glare, you see that it's not.
Would you like me to show you some footage of the sun becoming larger as it comes in?
Does it have a solar filter on?
No, again, why are you going back to the solar filter?
Because the point of the solar filter is you remove the glare.
The thing is,
you can't tell what the sun is by just looking at it, because it is so bright, it glares, and that overpowers the sensor on lenses of cameras, and you can't look at it with your eyes because you go practically blind. But a solar filter removes 99% of light, I think even more, and that allows you to see the actual shape of things. That's the entire point of them. I mean, I'm not just making it up. That these things have been designed for years.
Okay, so for example, you try to explain it to a child, because I find the child's innocence on how they observe the world is much more pure and much more rational. And
I've explained these things to my kids. My 11-year-old asks me questions all the time, and I can show him evidence and stuff. I talked to him about the solar filter, and he totally understood that when you look at the sun, it seems bright and glary. But if you remove that glare, you can actually see the proper shape of it. That's the entire point of a solar filter.
Closer to you, so obviously the solar flare is going to be more. So that should not even be taken into account whatsoever.
I'm not talking about the solar flare. I'm talking about the glare of the light.
The glare of the light is more because the sun is coming closer to us, and it's bigger, obviously.
Yeah, but okay, it doesn't explain why when you take away that glare, the angular size doesn't change.
First of all, you haven't shown me any footage of taking away that glare. But when you explain it to a child would be like, the sun is closer, hence the glare is more. And the sun goes back, and hence the glare is less.
Yeah, so remove that glare. That's the point. Take away the glare. If you can't tell because the glare's there, take away that glare.
That's the kind of intelligence right there. I mean, I understand there's different levels of intelligence, but the way a child understands the world is much more simpler.
Yeah, Mike, honestly, Mike, you keep saying that, Sonny, but my kids understand it. I explained the solar filter to my 11-year-old, and he was like, "Yeah, that makes sense." Why do you wear sunglasses? Why do you wear sunglasses?
To avoid the sun's rays, yes.
Yeah.
What does that have to do with this at all?
Because it allows you to see more because there's less glare in your eyes.
Okay, so I do see the sun. Okay, that's a good example. When I wear sunglasses and I see the sun, it's much bigger, right? In the midday or whatever. There you go.
Sunglasses don't remove 99% of the light, but what you'll be able to do is see more of the sun than if you didn't have the sunglasses. But a solar filter, let me see if I can get. I'm sure there is one.
Yeah. There's that.
Come on.
So that's a big one to me. I mean, that should really be. I mean, you can't just say solar filter and escape out of that one. I'm sorry.
Exactly. That's exactly what solar filters do. I don't know. I don't understand your problem with it. Like,
I don't. I'm trying to look at the world through the eyes of a child. As you know, I don't mean to bring up too much scripture. As the kingdom of God belongs to a child, whereas Satan has always been the one that complicates things or adds things to confuse us. But
yeah, but
it's all.
honestly, Sonny, a book says a thing. I don't hold much status in that.
I see.
Like, I mean, the Bible means nothing to me because the Bible is demonstrably not true. For instance, the Bible says that pi is 3, which we know isn't the case. So, I mean, if we can prove that the Bible is wrong, then why should we listen to scripture about anything?
Oh, so you can prove the Bible is wrong?
Oh, absolutely. The Bible says that pi is 3. Okay,
Where does it say that in the Bible?
I'll get you the one. Oh, come on.
So 1/3 of a pi. Let's see.
Okay, I'll get the
So,
actual.
let me ask you a quick question. This is just a very quick question. If tomorrow you woke up in the morning and you don't know a thing about the globe model at all, you just wake up, you see the Earth, what does it feel like to you? And you have no knowledge of the globe.
Feels like I'm still.
Nothing.
Feels
There you
like
go.
I'm possibly having
Very
constant
good.
motion, but I don't know. But it feels like it's still.
That's a
But
good
that's
start.
because there's a
Exactly.
constant motion, and you don't feel a constant motion. You only feel
Again,
changes in motion.
You're adding things to it, my friend.
No,
do you mind if I
I'm-
call you?
Yeah, but the thing is, if you were to wake up on a train that was traveling at 100 miles an hour, and it was perfectly like not rocking or anything at all, and you were just in a room, you wouldn't know that you were moving at 100 miles an hour.
If I was on top of the train, I would not even be able to stand on it. Like the train
That's
would
because
just
there's
fling me.
air resistance. Yes.
Again, there you go, another word, air resistance.
Well,
Right.
yeah, you can't deny that air resistance is a thing.
It seems like you're adding on top of something that's very simple. Say, for example, this I don't know, this bowl is orange, but you can come in and say, oh, it's not really orange. It's your eyes that are deceiving you. I mean, you could
Well,
find.
I could come in and I could define the wavelength of light that is allowing you to see it as orange because, yeah, we call it orange, but what you're actually seeing is a specific wavelength of light. So there's more to it than it's orange, right? Let me ask you this question. What happens when you turn on your light switch?
The light goes on.
Is that
The
it?
electricity goes. No.
Oh, no, you're adding more to it. You're adding more to it, Sonny.
Yeah, I understand, but
Do you see my point?
it's not a light.
There's
the sun
something,
is not-
there is more things that you have to take into account.
Yeah, of course, you're explaining how it happens, but the fact is the light has been turned on. And if I move the light closer to me, the light is larger. And if I move it away from me, the light is obviously going to look smaller, right? I'm not going to say, oh, because
But
the
that,
solar
and-
filter.
but it doesn't
like that.
happen. If you had a solar filter and
Yeah.
something was the same size, you would notice that it was the same size. That's the thing. I don't understand your disconnect here, Sonny. A solar filter isn't tricking you in any way. It's not doing anything magic. It's just blocking out 99% of the light. Do you agree that that would allow you to better discern the shape of the sun?
Let's bring it down to a micro.
No, come on. Answer my question. Answer my question, bud. Do you agree that removing 99% of the light would allow you to better discern the shape of the sun?
Well, the sun is basically light, so.
Yeah, but you're
Not
removing
sure.
most of it. You're removing 99% of it. So would that allow you to see the shape of it better?
Yes, I do believe it, and you still.
Well, there
have
you go. That's the whole point of a solar filter. It is removing most of the light, allowing you to actually see what the shape of the sun
And the
is.
sun would be larger. I'm 100% convinced, and in fact, I've sent you a link.
let me
If you want to
put that
look
up.
at that, sure, no worries.
Uh,
But let me ask you this question: say you have a light bulb,
yeah, no
and
solar
you bring
filter.
it. Yeah. and you bring it closer to your face.
Yes,
And then
of
you
course
move
it
it.
would, because it's small and local. But that's the point. The sun isn't small
That's
and
what
local.
I'm saying. It's small and local. The sun is small and
Yeah,
local. It's much
but the
smaller.
evidence that the sun isn't small and local is that it actually doesn't change in apparent size when you look at it with the proper equipment. If the sun was small,
Again,
yeah, but sorry, Santos, let me get to this. If the sun was small and local, putting a solar filter on would not change the fact that it changes in angular size. If the sun was small and local with a solar filter on, the sun would still change in angular size. But if you put a solar filter on, the sun doesn't change in angular size. You understand that, right? It doesn't change in angular size. Just saying it does because it looks like it does to you isn't an answer. You cannot see past the glare of the sun. You need to remove most of the light to properly discern the shape. But back to the Bible thing. Yes, absolutely. In 1 Kings 7:23, it says, he made the sea of cast metal, circular in shape, measuring 10 cubits from rim to rim and 5 cubits high. It took a line of 30 cubits to measure around it. That means that pi is 3, according to the Bible. Pi isn't 3. Pi is 3.1417. So, therefore, the Bible is falsified.
I mean, just because they got it off by a few decimals, it doesn't mean like it's completely
No,
false.
They said that a universal constant was something that it isn't. You cannot change pi because that's the ratio of a circle for its circumference to its diameter. You know, it's just what it is. And if the Bible gets something like that wrong, then I don't have to listen to it about anything.
Oh, wow.
Because I can falsify that it doesn't know what it's talking about. I mean, honestly, I hold very little, care about what Scripture says because it actually has no impact upon the physical world.
Mm-hmm.
The evidence I've shown you that I mean, does that not make you think that maybe I am wrong? I've shown you that with the correct equipment, the sun doesn't change in angular size. I've shown you that the Earth empirically rotates. I've demonstrated that zooming in on something does not bring it back above the horizon. I've shown you that if astronauts were in water, their heads would look smaller than normal due to refraction, but that doesn't happen. When we see astronauts, their heads look normal, meaning they're in space, not in a swimming pool.
And there's angles of the camera to consider. There's all kinds of stuff.
The angles of the camera wouldn't reduce the size of a head like that. This is straight on. It's absolutely straight on. So
you seem to only have 2 photos of him. With
that was just a quick one. That was just a quick one that I grabbed. But there's a lot. There's a whole website about it, I think. But
I can show you footage of the underwater footage where the head is not smaller.
No, you can't.
That works for you.
It would always look slightly smaller.
Yeah. But getting back to that. So I did. If you want to share that link, I did send you a footage.
I mean, I can share it. But like I said, that's where is it?
By the way, there's a globe believer saying, "Why are you measuring lens flare? You need to get a real solar filter." So it seems that it's not enough.
That's what he's saying. You need to get a solar filter.
No, we put a solar filter on it, but he says that we need a real one. So, I guess it's never enough, the evidence, empirical.
They're zooming in on that video.
But yeah, the solar filter is on the.
Yeah, let me just get that up for everybody, and you can see that they zoom in on the sun, meaning of course it's going to change in angular size if you zoom in.
But I've personally seen the sun on my own with my own 2 eyes, and I mean I can only say what I see, right? I'm not. Maybe I don't have your level of physics knowledge, but
like the fact that there is lens flare, I mean, yeah, he's zooming in and then trying to claim angular size, but the fact that there is lens flare shows that it's not a very good quality solar filter. I mean, you can get a decent one for 20 quid off of Amazon. I don't know why they've got that looks like some kind of negative shoved in front of it, honestly. I can show you evidence that isn't the case. I mean, because look at the difference of that, right, to that. There's no glare at all. Do you see what I'm talking about? How can you discern what the size of this is when there's quite clearly a bunch of glare on it? You can't. You need.
Well, we'd love.
He's right. Get a real solar filter. Sonny, like I said, get one yourself and do this for yourself. Because if that is what convinces you so much, get a solar filter. Get a good solar filter and convince yourself. Don't believe me. I'm not asking you to believe me. I'm asking you to consider the evidence and reach a logical conclusion.
Oh, I don't need to convince myself really about this because I just.
I mean, honestly, it sounds like you do need to convince yourself. You ask these questions and then you just deny my answer when I've explained to you what's happening. You can't deny that this is better than the video that you've given me. Like, how can you tell anything from that? There's still glare. On this, nothing. You can see a perfectly clear plasma.
Here. Whereas at least I'm showing you footage. You're showing me still images. Whereas
that's because they got much better quality. And this is throughout the entire day.
Yeah, obviously.
But again, do it yourself, Sonny. Don't trust me.
I don't know if I'll be able to get the quality that you need, but okay.
If you get a decent solar filter, you can. Honestly, I will find a solar filter and send you a link to one. All right, to make sure you get a decent solar filter and do it yourself, because the evidence is there. Okay, evidence that there is. Let's talk about some more evidence. We briefly glanced over it yesterday. Where's that picture? So, here's this. We talked about this yesterday, didn't we?
What is that?
Oh, did I not talk about this with you yesterday?
Yeah. But,
so, someone actually sent me a picture to help explain, which was probably better than I can draw, but where is it? Let me find it one sec. There we go. Open link. Thank you, Izion, if you're watching today. I mean, it's not a brilliant picture, but it explains what I need. They just drew this and sent it to me while I was talking the other day. So the point of this image, right, is that the camera height is at 210 meters. And that's verified by the video. There's a plaque actually next to it, right? The top of those bridges is 210 meters. The hills in the background are 500 meters plus. Can you explain how that's possible on a flat Earth?
So yes, I remember talking about this with this Team Skeptic. I remember this one. Yeah. So yes, I will admit there is some. I mean, I'm an honest man. I do think there's some truth to this image. On a flat Earth, those mountains would not be on the same level.
They'd be higher than the red line if the Earth was flat.
Yes, but that being said, what is the actual height of these hills?
500. The one on the right hand side where the peak is 537 meters above sea level, I believe, which is more than double the height of the red line. And
are there any other photos like this one?
Miles has so many. I'll give you the link to his channel, Miles Davis. But he has a ton of observations that are similar to this that he's taken around Scotland, like absolutely loads, and they all kind of show a similar thing, where something in the distance appearing below what it should based on eye level. This is just one of the best ones that he's ever taken, and is kind of another complete flat Earth killer. There is no way that this could happen on a flat Earth. It can't be because of perspective or anything, because as this picture drawn by one of my subs shows, the eye level is the red line. Perspective would make nothing fall below the red line, because that is your base, that is your eye level. There is no way that you can get something that would shrink below that red line based on perspective. It would go into the red line. So the only explanation for that is that there is a drop. There is actual curvature.
But of course, as you know, the horizon always rises as you go higher.
No, it doesn't.
Well, I've shown you a lot of some footage of that.
Let me show you this. horizon does not rise to eye level. As you can see, that the perspective lines show you what eye level is. There's another one there. And my favorite one, if the horizon always rises to eye level, why is the moon below eye level?
Well, the moon comes in and goes out.
Yeah, but
right? Like,
the horizon should be at eye level. So there's no way you could see the moon if the horizon is at eye level. The eye level.
You mean from
eye level is the middle of that. If the horizon rose to eye level, that the moon would be under the horizon.
Okay, I did want to add one point by from Ramakrishnan about that photo that you just showed. So he says that it's entirely due to perspective, and why other bridges don't show such effects. The bridge is too small for that much difference anyway.
No,
and it does rise.
Not. Perspective doesn't explain it. As I explained, perspective can't explain why something falls below eye level. Perspective would make it shrink into that red line, not go below it. It's completely not explainable by perspective. Because imagine if the red line is sea level, right? Nothing would sink below that based on perspective. I mean, and if you're talking about perspective, I have to ask, do you know the formula for perspective? I probably don't think you do. But...
No, I don't know the exact
Alpha equals 2 times the arctan of G over 2R. And we can use that to calculate this. And we get the exact what we should see. Perspective can't explain this, Sonny, like at all. There is no way to explain this with perspective. Because perspective, the eye level is the same as that red line. The camera is the same height as the top of those poles. Nothing would fall below that red line.
Same way we can't see quite as far. Like if you see a railroad track and it just sort of goes to the point of convergence, right? So it appears like it's going to the same point and kind of uniting, but it's actually not.
Yeah, but the point of convergence on this picture would be the red line.
Yeah.
Nothing would go below it.
Mm-hmm.
Come on, Sonny. You have to see that. Perspective can't explain this. It cannot make something sink below eye level. That's literally not how perspective works, like in the slightest. I mean,
yeah, well,
we talk about Soundly's images from Lake Pontchartrain, literally showing the curve of the Earth.
The actual curvature right there. Some globe believers do post this actual curvature. This image that you're just showing right now.
Yeah. I mean...
that's the actual curvature.
Yeah,
sure
it's been modelled in Walter Bisland's curve calculator, and it matches globe predictions. What you're seeing is compressed perspective, right? Which means the further... You're a digital artist, you should understand this. The further into the image that you see, the larger distance over the same amount of pixels makes the perspective appear compressed, allowing you to see the curvature more easily. That's kind of... I mean, you're a digital artist, you have to know that.
Yes, but there are, like, have you seen other images of the same bridge, like from overhead?
Yeah, that don't have the compressed perspective that allow you to see it. Thing is, Soundy went there live and was actually going from the position where you could see it where it looks flat to getting the correct perspective where it looks curved. But it's all about the position that you can be able to view it from. And when you get that compressed perspective, you can actually see what the curve is. Here's more evidence that the horizon doesn't rise to eye level and that there is curve, because the water level is connected here in the pipe. So that means the water is the same level on each side, yet the horizon is below it, showing that there's definitely drop in horizon based on altitude, and that the Earth's a sphere. Come on, Sonny, I'm showing you so much evidence here. These things are impossible if the Earth is flat. Absolutely impossible. There is no explanation for how these things can happen if the Earth is flat.
It's quite an interesting look at things. I'm just absorbing as much as you are. As any other legit flat earther.
Let me just play you another quick video. This one comes from one of the kings of your movement, Jeranism. So just bear with me for 40 seconds.
If you're seeing through this hole, through the next hole, and seeing the light at the backboard, or at 17 feet off the water, the Earth is flat. If he's holding it up at 23 feet high and we're seeing the light, well, that's because the Earth's curved. So I should only be able to see it when it's at 17 feet. Okay, go ahead and drive down there, Enrique. You're going to hold the light there. Enrique, how high is your light?
Oh, yeah,
I mean, you know, it's as, we don't see you, Enrique. Lift up your light way above your head. Interesting. Interesting there.
I mean, what else do I have to do, Sonny, apart from show you all the undeniable evidence? If you're a smart guy, and I'm going to stick with the contention that you're a smart guy based on your YouTube channel, you have to be relatively smart. You have to get this.
Yeah. Well, there's different forms of intelligence. You can be a complete genius in one area, a complete moron in another. Right? That's
yeah, but I don't want to believe you're a moron, Sonny. I don't want to believe that you're a moron. I think you're a smart guy, and I think you can get this. And
I'm not saying I'm.
I want you to just maybe do a bit of studying of basic physics. What's your physics education level?
Oh, it's very
high school, right?
Just basic. Yeah, that's it. Yeah, I'm very honest with that.
Take a college level physics course online, and I guarantee you, by the end of that course, you won't be a flat earther anymore. I guarantee it.
Well, you have to be indoctrinated. I don't know.
No. Education isn't indoctrination, and like I said, physics, you have to practically demonstrate things. And if you learn these things, there's no denying what the reality actually is.
Mm-hmm. Well, I like to keep it simple, but I do know where you're coming from.
The thing is, not everything is simple. There is deeper meanings and deeper answers to things. You know?
Right. About is something that was not created by man. Let's be honest. This was not created by man. Can you agree on that at least?
Earth wasn't created by man, no. But that doesn't mean that the physics isn't the same. And the only reason why we can do amazing things with technology is because of our understanding of the natural world and our ability to now manipulate it.
Mm-hmm.
Honestly, I've thrown all the evidence I can think of at you right now, and like, you just have to understand that with the correct tools, you discern what reality is.
And yet, with all your evidence, you still can't produce an actual video footage of Earth, and you still have to rely on CGI as your background there.
Yeah, because again, you can't find 100,000-foot high letters that say FTFE rotating around the planet. And also the rotational velocity of that would make days about 20 seconds long. I wanted that to look cool, you know, and it was created for me to look cool.
Oh yeah, I get that, but still, NASA.
It doesn't mean that there isn't those images. I just, there isn't an Earth that has massive FTFE letters that gives me a consistent, lovely picture. You know, that's a bad argument. It's been used a lot, but it's a bad argument.
I'm saying like, if the Earth was a globe and we've done all this space travel, all this amazing stuff, you would think that there would be hundreds of thousands of stock footage of
there is
actually.
There
yeah,
is.
but no, there is actually. Well, you claim that it's real, and the clouds are not moving. There's no stars. The sun is like just, I don't know what the heck, where the sun is in that. There's no. And I think in our last debate, Team Skeptic and I had a bit of a debate going on why the clouds are not moving. And though you're saying that, the Earth is spinning, but the clouds are just going to be stuck to the Earth. Because
they're rotating with, like I said, everything's rotating with the Earth, but have a look at this time lapse of...
Exactly
Never lets me...
Of the Earth. Is that what you're saying?
Say again?
The clouds. So you're basically saying that the clouds appear to be stuck on the Earth.
Well, not completely. I mean, watch this, and you can see the cloud patterns changing.
this is real to you. This
Well,
sun
this is time lapse from Himawari.
Himawari is not real footage, by the way. It's
But
data visualized.
No, it's real
Right.
image.
It's similar to the blue marble. It actually uses the same satellite, so-called satellite imagery.
The only thing it uses from Blue Marble is for the outlines of the continents and stuff. But
why is it used? I
be-
just want a straight up photo.
Why
footage.
is it? Well, then you take off the outlines. Like I'll show it you live right now without the outlines. Okay.
Okay.
I've got it programmed in here.
That
All you got to
sun
do to see the actual image is click that until the outlines go away. Those are just there to show you where the continents are. Come
Now,
on.
you're
Go
saying
away.
this is real.
Let me get rid of the lines and I'll show you. What's going on? Mouse enabled. I can't seem to get rid of the lines. The web browser is going to be a bit dodgy. But like, you can show yourself that this is real by looking at traffic cams in Australia, and it will show you the same cloud patterns. Right. Can't seem to click on anything on here. One sec. Oh, right. I think the web page may have crashed, but you can remove the outlines, and then it's just a pure image from space. But
Right.
you can't say this is created using data from Himawari, and you can see the clouds are moving exactly as they should be over a day.
And that's the actual sun going over the Earth. Is that,
Yeah, you can see the reflection of the sun actually off. There we go. You can see the reflection of the sun because of the spherical nature of the Earth. And again, that's all. You can model
Looks
this
like
out in programs like I don't know, say Universe Sandbox, and you get exactly the same thing.
Did the Earth forget to spin 1,000 miles per hour?
The
It looks
Himawari is
Earth.
in geosynchronous orbit.
Oh, right, of course. It's perfectly in sync with the Earth, so you don't even see
Do you know what a geosynchronous orbit is?
I know that it's perfectly synced with the actual spin of the Earth. Is that
Yeah,
what you're,
they have to be exactly 2,267 miles up, and it's where every single satellite TV satellite is placed.
So it's perfectly synced to the nth degree, something that's moving at 1,000 miles per hour. Does that seem logical to you?
It's moving at 15 degrees per hour.
No error at all, not even a smidge, not even a slight shift, nothing. Perfect, absolutely.
That's what geosynchronous orbit is. They have to be at that position to
There's
maintain
no
that.
room
Right, no, wait, Sonny, stop. With a geosynchronous orbit, you have to be at a particular height to exactly match the rotation of the Earth. And when you are in that orbit, that is exactly what it will look like. If you fell out of that orbit, you would no longer have a geosynchronous orbit. Every single TV satellite is placed in a geosynchronous orbit. And every single satellite dish installer has to point all their dishes at exactly the same point in the sky. And if you match up all those vectors, you find something that's 2,267 miles above the surface of Earth. These things aren't hard. Like
I understand. It just seems extremely logical to me that it's like it's perfectly in sync with no error whatsoever. And also satellites can, I'm sure you've heard that the underwater cables and actually radio towers is how we get satellite, so-called satellite television. It's not actual satellite in space.
Yeah.
Oh, by the way,
Sonny, I could still get those things in the middle of the ocean. How is that possible?
Well, radio waves can be just as strong. It can transmit quite a distance. And
Sonny, I can use a satellite phone, which doesn't use radio signals. In that way, I can use a satellite phone in the middle of the ocean, but I cannot pick up a signal on my cell phone. Why is that?
Again,
remember, I'm ex-military, ex-Royal Navy. I spent a lot of time at sea.
I respect that. But that being said, why do we need cell phone towers if it's all satellite?
To transmit the signal out,
Exactly.
to the local things. But that cell phone signal doesn't come from satellites. Cell phone signals are transmitted to local towers and then through that network.
Yeah.
And that's why you
That's-
cannot get a cell phone signal in the middle of the ocean. You've just proven my point for me.
You can't get it, and there's no satellite providing that for you either. Is what I'm trying to
You
say.
can get right, listen to what I'm saying. In the middle of the ocean, I cannot use my cell phone. This will not work. But a satellite phone does. You can get a satellite signal for satellite phones, but this does not work in the middle of the ocean because there's no towers out there.
So a satellite phone could have its own kind of like, extra sensors that can pick up more radio waves.
It has
Every phone does.
satellites. All right, answer me this, Sonny. Why is the GPS receivers on planes placed on the top?
To map out the Earth, right?
No.
Why are they?
The GPS receivers on planes are on the top of the planes, looking up into the sky, not looking at the ground. They're looking at what's above them. What's above planes? Space and satellites.
Interesting. I did not know that they were placed on top of the plane.
Yeah,
that's
GPS receivers on planes are on the top.
Mm-hmm.
I mean,
and another thing is about speaking of satellites. There's never ever any footage of satellites ever
yeah, there is.
on film. Can you show me any? Like while
What you mean? A picture of a satellite from another satellite?
Well, there should be thousands of satellites.
Why satellites aren't looking at other satellites? Most satellites don't even have cameras and stuff on them. They have like data sensors.
I mean, like when you show me the Himawari satellite, which you claim is actual footage, whatever, you never see any satellites going. There should be thousands of satellites, like all the rotating.
Oh, dude, come on! The Earth's massive. Satellites are tiny.
Again, that it seems like you use that argument a lot. Like, why can't you see
It's just
the
a fact of nature. Do I have to play the Father Ted clip for you?
Well, I mean, it seems that you're using the same argument. Why can't you see the curvature from 100,000 feet?
Because the Earth's massive. I mean, you can't deny that the Earth's massive.
I'm not denying the Earth is massive. I don't know what the Earth's size is, but again, it seems like
we've mapped the Earth quite conclusively. Cartographers have been a big thing for thousands of years.
Oh, I totally respect that. I 100% respect that. Have you seen the satellite footage being launched on balloons, like actual satellites being launched?
Yeah, well, there is things called satelloons. There is some like weather monitoring things and stuff, but again, that's not a secret. That's not the same as satellites.
I understand, but I've seen videos of the satelloons or whatever they are, but I haven't seen satellites that are in space.
That's because you're not in space, dude.
Huh? Pardon?
Because you're not in space.
I'm not in space. I never said I was.
Okay, one last time. These are small, but the ones out there are far away.
That's kind of my point.
Okay.
Things look big and small based on your distance away from them.
Yeah, but can you answer that one though? How come I can see footage of satelloons or whatever they are, but I can't see footage of satellites in space?
Because you're not in space.
No, I'm not in space. I want to see footage. Obviously, only.
Right, so you want another satellite up there taking footage of the satellites?
Well, okay. Well, say for example, the astronaut is repairing the Earth, the ISS or whatever that is in the swimming pool. Whatever it is, maybe, as you say, maybe it is real. I've never seen a satellite whiz past him or anything like that ever.
Get the app on your phone. Get the app on your phone, and next time the ISS is transiting the moon near you, just record it.
Pardon?
You can get an app on your phone that will tell you when the ISS will transit the moon based on your position.
Okay, I've seen footage of the ISS. There's no denying that. There's, by the way, the ISS is not as far away. Otherwise, we wouldn't even be able to see it.
No, it's exactly that far away. As I explained earlier, based on purely empirical parallax measurements, they were able to determine the height, velocity, and size of the ISS. It's undeniable empirical evidence.
I understand. So I can see the ISS, which is only one, by the way, right? But I can't see the thousands of satellites.
Oh, most satellites are probably about this big, right? The
No, they're
ISS
quite-
is no. Most satellites are about this big. Most of the satellites in space are between this big and maybe the size of a car at most. The ISS is the size of a football
Alright,
field.
there-
Yeah,
So,
but
sat-
most
yeah.
most are only about this big.
So hold on. So how big is the ISS?
About the size of a football field.
Okay, how big is a school bus?
Not that big.
No.
A rough guess, I'd say you could fit 30 school buses on a football field length.
Yeah. So okay. Let's go to the back. Okay, 30. So you're telling me thousands of satellites that are the size of a school bus cannot be seen at all whatsoever because the
Well,
Earth is too
they
big.
can. You can see satellites all the time when you look up in the sky and see the light.
But I can't see
And
satellites.
you know how you can tell that you're seeing a satellite across the sky is because it doesn't blink, right? When you see a solid light crossing the sky, and again, you can get apps to track the satellites to verify what you're looking at, right? And you see a solid light going across the sky. That's how you know it's a satellite, because planes have strobe lights that are there to enhance the visibility of the plane and the pilots and stuff. So you know you're not seeing a plane and stuff. So yes, you can see satellites from Earth. In fact, especially now, thanks to Elon Musk, he's got, 120 Starlinks up there.
Oh, listen, you said there's also satelloons. What's the evidence that they're not just satelloons? They're just putting up there to make believe that they're satellites and not actual satellites.
Well, the satelloons can't travel at the speeds and everything. Yeah, how would you control where that's going?
I don't know. I'm asking
the
you.
satelloon things are like they just go up there for a little while, take some measurements of the weather and stuff. Whereas satellites are in orbit, you can track them day after day after day, and they are where the things say. Satelloons wouldn't be able to move at those speeds.
No, absolutely not. You're telling me that the satellites in space cannot be viewed because they're too small, when I just proved to you.
No, but you
that
can't. I'm saying that you can see the light from them. The light's reflected from the sun quite easily. Especially now with Elon Musk's Starlink. Like, there's hundreds of these things flying in a massive chain.
I would love to see.
Again, get the app on your phone and do it for yourself. Don't rely on footage, Sonny. Don't worry about getting footage of it. Do it yourself.
Why not though? I mean,
because then you can prove it to yourself.
What's the best evidence in court? What's the best evidence? Answer me this.
Science isn't decided in court, though.
No. In court, what is the best evidence? A man robs.
Honestly, I've never been to court.
No. Let me answer.
Most of it's circumstantial, right?
Very, very simple question. What do they have in stores to make sure people don't steal? What is
CCTV?
Number one. What is that? Can you repeat it?
CCTV.
Yes, exactly. Okay, security footage. I used to work in a electronics store, so.
Yeah, what's that got to do with satellites in space?
No. I'm just asking empirical evidence that can be held in court. Now, the laws of physics, right? Let's look at the laws of, human laws, okay?
Yeah.
What is evidence to prove that somebody stole something in a store? What is the number one proof?
Well, if you've got CCTV, of course you're going to refer to that.
Yeah. So now, $65 million a day or whatever crap amount of money, these people cannot have a CCTV camera on the moon because China has sent, I don't know how many missions to the moon. They can't install, they can never install a camera. But, stores can have all kinds of, just a basic convenience store can have all kinds of security.
You want NASA to go to the moon and install a CCTV camera just to prove to people, right? NASA don't care about proving anything. And that $53 million a day goes to paying for the buildings, paying the wages of the 18,400 employees, the development of new technology,
Again, you use that word, NASA doesn't care. That's an emotional argument. That's not logical.
No, it's true. It's a fact. It's nothing emotional about it. NASA don't care. NASA aren't in the business of proving things to flat earthers. NASA are doing what they are doing to advance our ability to travel in space.
Their job is to show us what space is.
No, it's not. No, it's not. Their job is not to show anyone anything. Their job is to advance our knowledge around exploring space. NASA's job is not to prove anything to anybody.
That's like me saying I work at the bank, but my job is not to count the money. That's basically what you're saying.
No one ever said that NASA's job was to show you things. That's not why NASA was created. NASA was created to advance our knowledge around aeronautics and space travel.
You said that NASA doesn't care about what we think, and now you're saying it's to advance our knowledge.
The humanities knowledge. That's what they're doing. But they don't care about proving anything to a flat earther. Why would they care about, why would they spend millions and millions of dollars to prove something that they already know to be a fact?
What fact? There's no
the
footage
Earth's a
of
sphere.
that. I could say there's a pink elephant in my room.
Prove it.
And I could say, oh, I don't have to prove it. I just told you. I could prove it on paper.
No, you can't.
But I don't
Show me it on paper.
Huh?
Show me it on paper.
I could say that. I could
NASA's
even draw
taken thing is, Sonny, NASA has taken plenty of pictures from space. I can show you them all the time, and you just deny them. But NASA don't want to prove anything to anybody because that's not their job. They just want to advance humanity's knowledge around traveling in space, and that's what they've been doing on the ISS for the past 20 years. And now, in 2024, NASA plan on going back to the moon to create a sustainable, permanently manned base. Boosted up by the private space industry. There is currently 47 different missions planned from private space industry to put stuff on the moon in preparation for NASA returning there. The past 20 years of being on the ISS and figuring out how our bodies work in space and how to survive comfortably in space has been doing that so that we can then go to the moon, have a manned base, go to Mars, maybe go to the moons of Saturn and possibly find life on one of the moons around there. It's not that they don't care about proving something to you, it's not even on their mind.
Oh my gosh. Well, they've sent rovers to Mars, which is like supposed to be much bigger than the moon, and sent pictures from there. Why don't they just send a rover to the moon and just take a picture of the flag they supposedly left up there?
They're going back to the moon, like actual people are going back there.
But it's been what, 60 years now?
Yeah, but they did as much on the moon as they could. They've taken pictures of rubble. There was a bunch of pictures taken from the moon of Earth. Why are they going to spend millions of dollars to put a rover on the moon just to take more photos to discover what they already know? They're not going to. Why? Well, China's done that. Well, to be honest, the flag wouldn't even be there anymore. It'd be destroyed by solar radiation.
Can you please show me China's footage of the American flag that's been up there? I'm waiting.
Again, the flag probably isn't even there anymore due to solar radiation.
Why isn't it there anymore? Why isn't it there
Are you not
anymore?
listening to the words I'm saying, Sonny? Solar radiation would have destroyed the thin nylon material in the harsh vacuum of space.
This is a very new argument.
It's not, it's true.
So I guess you're preparing for the 2024 when we do go there and people ask that question, you'll be like, oh, flag is not there anymore.
They're not going to the same place. They're going to a different spot on the moon. Why would they go back to the same place they went before?
I understand. You realize if they don't go in 2024, it's over.
No, it's not. There's a chance it's going to be delayed anyway. But it's going to happen.
Think of the people like a common people do think like a child. I'm sorry, but maybe they're not as smart as you are. Maybe I'm not as smart as you are. But the thing is, people ask basic questions, right? Let's face it. People ask basic questions. Okay? They ask, okay, we've been to the moon, 50-something odd years ago, and some Don Petit, some guy in NASA said, we've destroyed the technology, and it's a painful process to build it back up again, which makes zero sense. Every other technology has progressed, except the moon technology.
I've got to stop you there. Are you saying that space travel technology hasn't got better? Is that what you're saying?
Not according to Don Petit.
No. He said that specific technology that they had back then was destroyed. They didn't need it anymore. But my question to you, are you saying that technology around space travel hasn't got any better? Is that your claim here?
No, it hasn't gotten better. No,
are you sure about that? Do you really want to?
My cell phone camera, 4K, has 4K in it.
I don't care about your cell phone camera. Are you really saying that technology around space travel hasn't got any better?
No. How many
Okay.
people have actually?
Tell
Can you answer
me
that?
what this is then, because this is some of the most incredible technology that has been designed recently.
Pretty much the same thing as they did in the 60s.
Nope, they did not do this in the 60s. You wait and see.
Okay, so they can put a rocket that goes up and down. This has already been supposedly done.
Not like this. This is
Okay,
advancements
use that
of technology. This is reusable rocket parts, which we didn't have before. See the Apollo rockets, right? Once they're
wasn't that-
expended... Wait, Sonny.
Yeah.
No, this isn't Apollo. This is SpaceX landing their reusable boosters, right? But the Apollo missions, once those rockets had gone up, they were used, they were expended, they couldn't be used again, right? And that's millions and millions of dollars for every single time. Whereas what SpaceX have done is create rocket boosters that can be reused.
Okay.
And that's an advancement in technology. Blue Origin also, I think, where's the Blue Origin footage? Yeah, here's Blue Origin doing their new Shepard test. This is sped up a little bit for my video, but...
By the way, have you seen those footages of the rockets hitting the firmament? Have you,
yeah, they don't hit the firmament. There's a maneuver called a brake thrust where they stop spinning on purpose to align themselves with the orbital velocity that they need. No, there's no pictures of anything hitting the firmament. We don't have a firmament. There's no such thing as a firmament.
Well, I can show you footage of that. What would you think if I showed you that?
I'd be able to tell you what you're looking at because it's not the firmament.
You're seeing footage of the rocket like suddenly getting like absolutely still.
Yes, and I
seen
just
that?
explained that's a braking maneuver that the rocket does so that it can align itself correctly.
No, this is an amateur rocket that was just launched, just straight up there, and then all of a sudden.
And how high was it?
Oh, it was quite high. I think it was. I'll look into the footage. Hold on. Rockets hit the firmament. But yeah, like back to the moon thing. I mean, so you really believe that we went to the moon in 1969?
We absolutely did. I bounced lasers off of the retroreflectors.
100%. No room for that whatsoever.
No, I like I said, I bounced lasers off the retroreflectors left there by Apollo 17. So I know we went to the moon.
Okay, so this 2024 is the big year that we're going to go back.
Well, that is what NASA would like, but Congress have already suggested delaying it for a little bit, but that's the American government. Right. I give it 10 years at a maximum when we're back on the moon, but I also give it 10 years and I think we'll have had something substantial on Mars, especially if Elon Musk gets his way. Elon Musk has plans to have 1 million people on Mars, I think by 2050 or something. And the thing is, Sonny, you're right? If these things don't ever happen, there's going to be a lot of questions asked, but they're going to happen. It might not be in 2024 because things get delayed. You have to remember that NASA is a government organization. It's not run by people deciding what to do. There's a group of old men sitting around in Congress that decide what NASA does.
They're still getting a whole bunch of money, though, don't you think? That's kind of odd
and every single cent that NASA spend is accounted for, and you can look at it for yourself on their website. You can see where every single bit of that money goes.
Yes. Because
they're a government organization, so they have to be transparent with their funds. What do you think they're doing? Do you think they just get a party of hookers and blow every day?
I don't know what they're doing. That's a good question.
They're developing space travel. Do you want a list of things that NASA have invented?
How many people have actually been in space?
546, I think.
I believe it's 24. How many people have actually been in space? It's very low. Oh, sorry. How many people have traveled beyond low Earth orbit? How many people?
Oh, not many people at all.
Yeah, 24. Though that's a very low number.
Yeah, that's because we haven't really had the technology to do it much. It's an incredibly expensive and exhaustive thing to send people beyond low Earth orbit. Sorry?
Is it the Van Allen radiation? Is it because of the Van Allen radiation belt?
No, not really. I mean, that's been an issue with modern digital technology. Obviously, technology is more digital than analog now. So we've had to develop ways of shielding against that, the radiation in the Van Allen belt. But if you're going to talk about the Van Allen radiation belt, can you tell me what it is?
Well, from what you've told me, like what I've heard
No,
from
no, no,
NASA,
no. You've just brought up the Van Allen radiation belts. So can you describe to me and the audience what the Van Allen radiation belts are?
Sure, it's like an energetic charged particle. It's like a zone that's surrounding the Earth, right? Like some
but
kind
not
of
really surrounding. No. How is it created? Like, what actually are the charged particles? Do you know?
No.
Right.
No.
Well, it's a lot of stuff coming from the sun that gets trapped in our atmosphere, and actually during the 50s they detonated a nuclear bomb to in the atmosphere to try and disperse it. It actually made it worse for a while before they went up. But no, the thing about the Van Allen radiation belts is that most of the radiation from it, I'm going to show you now what I could block that radiation with. You ready? Because I've got some of it here. So an incredibly rare material, right? Incredibly rare and expensive material that can block most of the radiation from the Van Allen belts. It's a bit of paper.
So
most of it's alpha particles that can be blocked by a bit of paper.
Wow.
There is higher charged particles that need a bit more, but the exposure time is so low that most of the astronauts received about 5 rem, which is about equivalent to a month's work during the Nuclear Energy Commission, you know, an average worker for them. So not really much at all. But no, most of the radiation in the Van Allen radiation belts can be blocked with that bit of paper.
Okay. But that being said, why is it that only 24 people in the whole history of...
Because it's really fucking expensive.
Again, that doesn't answer my question. Why?
It does. It costs a lot of money, and there was no reason to go beyond low Earth orbit recently because we went to the moon a bunch of times. We've done all the experiments that we wanted to do. Public interest in it waned, therefore the government gave less money to NASA to continue going back to the moon. So they decided instead to study the effects of space travel in low Earth orbit in preparation for missions in the future, which is exactly what they've been doing for the past 50 years. You know, that's why we have the ISS. It is there to study what space travel is like. It's there to study the effects of long-term space travel on the body. That's why we have the ISS now. And now we've got all that information, we know a lot more about space travel and how to make it safer and more efficient to get where we want to go. It's still bloody expensive. You know,
how expensive? Give me a number. How?
Well, it's all to do with the amount of fuel that you need to get a tiny payload off of the Earth. Right, that's what development of space travel is around.
So, well, it's, I mean, we'll wait and see, I guess. 2024 is coming, and if they're going to still make excuses, what would convince you that, I mean, how long will you wait until you realize, okay, we've never been to the moon, and we can't go back, or we've never been there?
I know that we have been. I can verify it myself. I have done, and so have lots of other people. This isn't an issue. We know we've been to the moon.
So even 100 years from now, if we never go back, you're still okay with us going that one time or that whatever 4 or 5 times?
Right. So let's make an assumption here that we didn't go back. Okay. I would look into the reasons why we didn't go back. Right. Now imagine in the next 3 or 4 years, before NASA's goal of going back, there was a massive global war that broke out. Right. Do you think NASA would still go back to the moon if that was happening? Or do you think the US government would divert their funds to help the war? Do you not think that there could be things that happen in the economical landscape that would change the US government's priorities? At the moment, they're pumping even more money into NASA because there is plans to go back to the moon. But if things changed and they took that money and put it somewhere else, do you think NASA would still go back to the moon then? Or maybe it would be down to private space industry, because there is a lot of private space industry stuff now. You know, most of the heavy lifting is going to be done by the private space industry.
I would love to see it. I mean, I'm not, like I said, I grew up...
It's an exciting time to be alive. It really is an
is.
exciting time to be alive.
Exciting that a lot of questions are also being asked.
I mean,
a lot of
it's depressing that the questions are asked and the answers aren't understood. I imagine if a scientist from the 1960s came forward in time, they'd be like, "Oh yes, flying cars, excellent." What do you mean people still think the Earth's flat? Oh, for fuck's sake!
Well, maybe
Because the
that's,
truth of it, Sonny, is the demonstrable fact that all empirical evidence actually gives you is that we live on a globe that is rotating at 15 degrees per hour and rotating around our star at 1 degree per day. These are empirical measurements that you can make, optical things that you can do. Use the correct tools to actually look at what you want. Look at pictures like this, which are impossible on a flat Earth, or absolute evidence like this that the horizon does not rise to eye level. Learn a bit about physics and the Sagnac effect. Pardon me. Study the LIGO and how that actually demonstrates the Earth's a curve. Get a solar filter for yourself and look at the sun throughout the day. Don't rely on someone else's video. If you really want it proven to yourself, if you don't think the what's out there is good enough, prove it to yourself. The thing is, people haven't been. There's not a lot of videos around it because the whole flat Earth thing is a relatively new online phenomenon. So there's not been people trying to prove the opposite until there's people like me that have come along, right? YouTube's been around for 12 years, though, right? So there's been 12 years of maybe flat earthers online and people arguing with them before they want to go out and get observations for the other thing. And in recent years, Red's rhetoric has been doing that. He's been getting observations that show that the Earth isn't flat and that it does rotate and that the ISS is in space. There's been people doing the observations now. It's all there.
YouTube is also opening a lot of canned worms because everybody with the phone
Unfortunately, yes, but that's why people like me are necessary to fight back against the nonsense.
I'm glad you're doing that. That's a very honorable thing what you're doing. I mean, I'm all for the globe believers presenting their evidence, and I am reviewing them. But it seems still like the basic stuff is maybe you should contact NASA and say sometime and say, listen, let's end the debate. Let's just put this.
I don't have anyone in contact with NASA, but I do have someone I've been speaking to that works for Blue Origin. I do have someone that works for the Canadian Space Agency. I've got 3 people that work at CERN, and they all are interested in helping me demonstrate this. I'm really excited about the Blue Origin guy. He can even arrange for me to have tours around their centre and everything. But because Flat Earth has grown as an internet phenomenon, more and more people are becoming aware of it, and more people will be able to demonstrate that it's not true. I'm going to be working with people throughout this year to conclusively show that the Earth is not flat. And Sonny, I've converted hundreds. All right, I get emails all the time of people saying, "You, Conspiracy Cats, Team Skeptic, Simon Dan have saved me from this flat Earth cult," and you're going to be one of them, Sonny. I'm going to save you. I'm going to convince you. Well, no. I'm going to get you to convince yourself that the Earth is not flat. That's my goal.
Well, maybe someday you will be convinced the other way. What will it take
my
to
degree in
convince you?
physics says that it's not possible. That unless someone could demonstrate to me that all of the physics I've learned and my understanding of the universe is conclusively wrong, I'm never going to be a flat earther.
Engineers use physics to build buildings, and there's a lot of wonderful things that physics given.
And you know what? The equation comes into most buildings and bridges is Fg equals gm1m2 over r squared, which is the universal law of gravitational attraction. They need to use this to calculate loads on bridges and stuff.
And yet engineers don't really take the curvature into account when they're doing their bridges or their...
Oh, they do.
Yeah.
The Narrows Bridge in New York has pillars at the top that are 1 3/4 inches further apart than at the base, even though the pillars are exactly level. So they do take the curvature of the Earth into account when building things, especially with something like this, the largest interferometric device in the world, LIGO. When building this, they the arms are 4 kilometer long vacuum tubes, right? They have to be perfectly straight for the laser inside. At the end of the 4 kilometer long arms, there was over a meter of drop that they had to use precision pouring with concrete to, counter the fact that the Earth had dropped away. So yes, they absolutely do take curvature of the Earth into account. And you know who else does? Is surveyors. They have to work with something called a spherical excess.
Mm-hmm.
And it's surveyors' job to survey the Earth, and they base what they're doing on there being a curve. Just look at a basic surveyor's manual. Don't believe me, just go to the surveyors.
Okay. You are presenting yours, and I just sent you a link. You can take a look at it if you want. It's just amateur footage of rockets hitting the firmament, and water is above, right? So when they hit, there's like a splash.
There's no water above us.
It's beyond the firmament. You can't. It's incomprehensible. Is God's actual. But anyway, you can present that video if you'd like.
Oh yeah, no, that's exactly the one that I was that you were saying about, and it's called a braking maneuver. Everyone's seen it. It's the one when the rocket spins and then stops. It's a braking maneuver that it does so that it can orientate itself correctly.
Oh my!
And the 73 miles up we've been a lot further than that. So the ISS has been confirmed to be 270 plus miles up. And that would be inside the apparent firmament.
Yet we can see it from the Earth somehow with binoculars, I believe.
With really powerful telescopes, yes, because it's the size of a football field.
Away? Okay, answer me this: what's further away, the satellites or the ISS?
Well, there's all different heights that satellites orbit at.
Okay. Are there any satellites that are lesser in orbit than the ISS?
Yeah.
For sure, right? Okay. So. There's a start. If you can get any, if you can, you understand what I'm trying to say, right? If I can see with my telescope the ISS, which I agree, people have shown footage of the ISS moving and everything. If somebody can capture a satellite that's much nearer to us and the size of a car or a school bus.
We have incredible zooms on cameras and telescopes.
Maybe in the future we would have that.
What you can see, if you're looking at a satellite, all you see is like a light, right? You can't really see the shape of it. The ISS, yeah, because it's the size of a football field, so you can kind of zoom in on that. But when you see a satellite, you just see a light. And no matter the size of the object, you can still see light being like emitted from it or bouncing off of it. If you can shine a laser like with a tiny small aperture for a couple of miles, right, where it's impossible to see the laser pointer, but you can still see the light from the laser.
Mm-hmm.
So, now come on, Sonny. I've shown you so much evidence that is entirely impossible on a flat Earth.
Yeah. And I've shown you some.
No,
right?
You've not shown me anything that's not possible on the globe Earth.
I've shown you footage, and I've shown you...
Footage of what?
Well, footage of the Earth. I keep showing you footage, but then you kind of seem to debunk it or...
Yeah, because it's very hard to see the curve when you're a tiny... 180 feet is like... like that. You'd be like, yeah, let's go even closer.
And yet some people have claimed that they can see the Earth curve from their airplane. Or
well, it's all to
like
do with field of view. Like I've said, a larger field of view, you can see a lot more. And also when you compress images from left to right, you can actually show the curve that's there even more. The curve is there, but it's so big that, when you're looking at a flat horizon, you're still looking at the curve. Look at this. This is a curved line. Right? This line is curved. But it looks completely flat until you get far enough away that you can see that, oh look, it's actually curved. You seem to have an issue with the aspect of scale. Earth's fucking massive and we're fucking tiny.
Mm-hmm.
Like, so tiny. Does a flea know that it's on a dog?
Yes, I think it does. But a flea may not have the comprehension but it knows that it's moving from one place to another. It can feel the shape of the dog as it moves. Whereas
I don't think
I
that
guess maybe
it
you
would
could
know. My point is that a flea could never see the whole dog, or
Right.
probably couldn't even see the curvature of the dog's back from its height above its skin.
Maybe
Anyway,
if it's a micro. Yeah.
I think it's about time that we start to wrap this up.
Okay.
It's 3:10 in the morning for me.
Wow, that was pretty
Yeah.
late. It's only 10, 11 here, so I didn't realize. Like,
Sonny, I'm
Wow.
going to have you back on. We're going to go over more stuff because
Okay.
But I want you to do what we've talked about. I would like you to get yourself a solar filter and observe the sun for yourself, right? And make sure you get a decent one. The video that you sent me, right? Someone's actually grabbed the info of this from me. The video that you sent me isn't even a solar filter. It's actually an ND filter, which I can get the Amazon link up and show it for you.
Okay.
Oh no, the Amazon link is actually for solar filters he was giving me for you. But no, anyway, that the filter on that video that you sent me it's an ND filter. It's not an actual solar filter. Let me just get a description of an ND filter. All right, it's a neutral density filter. In photograph and optics, a neutral density filter is a filter that reduces or modifies the intensity of all wavelengths or colors of light equally, given no changes in hue or color rendition. Unlike a solar filter, which is purely designed to remove 99% of light. So he didn't use the correct thing to remove the glare from this image, from this video. So again, of course it's going to appear that way when it's higher in the sky and brighter. But when you use a solar filter, you don't get that. Any final thoughts before I read out my super chats?
Yeah, it's been really great talking with you. I hope I've been as polite as I can.
Yeah.
And yeah, hope. I mean, I didn't rage quit or anything like that.
No, I don't need to up my counter. We're sticking at 4.
Oh, that's good. That's good. Like I like to be as pleasant as possible, and I hear a lot of what you're saying. I believe there's the answer is still up for grabs. What the Earth really is. I'm still with the idea that it could be a simulation, which Elon Musk himself has.
Yeah, I mean, it's true that you wouldn't know if you were in a simulation and the simulation was good enough. I mean, simulation theory is a completely unfalsifiable thing, really. But if you would like a conversation about simulation theory, then I think that's for you and Team Skeptic. We'll get you on his channel for that.
Oh, that'd be great. Yeah.
Yeah.
I'd love to do that.
Because I think he knows more about that than I do.
Yeah.
I'll make sure Team gets your email, and you and him can have a conversation about simulation theory. I'd quite enjoy watching that.
Yeah.
But I'm going to read the super chats, and we're going to get out of here for tonight, guys. Feel free to hang around, Sonny, because some super chats may be directed towards you. Warning, not all of them will be nice. BK Rich. BK Rich, new member. Welcome to the Scrappers. Thank you very much for becoming a member. Absolutely amazing. You can use all the fancy emojis. I'm going to be adding another one in the next couple of days, which is a face palm. So thank you for that. And remember, guys, I know not everyone can super chat. It's your super chats that keep allowing me to do this. But if you can't super chat, just watching my stuff and sharing my videos helps me more than you realize. Sparky NJ for $2. What's my name, FTFE? Yeah, I typed Spargy earlier, I think. I'm sorry about that. Rob I for $2. Sean Dorian compiles amazing 4K video from space. I know there's actually quite a lot out there. I'm going to try and get more and more on hand to show them. Craig Connors, excellent first name, for $5. You are on the brink of convincing one of reality. Also, thanks, Sonny, for actually listening, which is rare. Good job, Craig, and great name. Hey, Craig's got to stick together. Carrie Oliver for $33.33. Thank you very much. I think bouncing balls are tidally locked with Nathan Thompson's chin. Boom.
Oh, boy.
Nathan Thompson's dog, you still in the chat? Have you been fed yet? Probably not. Yeah, Kirsten Frost, you're right. A wizard hat emoji. My next debate with Flat Ferdinand, I'm going to wear like a full Gandalf outfit. Concord for $2 Concord327 for $2. Does he have any thoughts or just a parrot of Nathan Thompson? I would hope that he doesn't listen to Nathan Thompson, because that is a way to ruin your life. He might have had 8 shower heads, but they were in a house he broke into. No doubt for $5 says Nathan Thompson is a joke. A man-child, would love to meet him in person. Sonny, at least you're a civil man during debates.
Thank you. I love that.
Show your sources for $5 Australian. How about do it yourself? Absolutely. Agree 100%. If flat earthers want all this proof, go out and get it. Robert Williams for $4.99. Still images record significantly more data than video. Why would you want video? I can kind of understand why he'd like to see a proper time lapse, but again, he can get a solar filter. C4 for $5. Remember, everyone, Nathan Thompson said his brain training can make you taller and make your feet bigger. Apparently, it doesn't make you any smarter. N Flat Earth for $2. Nathan Thompson is a waste of atoms. Yes, absolutely. N Flat Earth for $2. Hashtag shun Natalie. Jonathan L for $7.99 Australian. Sonny, I accuse you of being part of the only conspiracy on the shape of the Earth. You rely on people's ignorance to suck people into flat Earth. People like you destroy people's lives.
Oh, wow.
Right. I mean, what do you think about the fact that in an attempt to try and prove the Earth is flat, Mad Mike Hughes killed himself?
Oh, right. Oh.
I mean, kind of think that Mark Sargent has his blood on his hands, but... B-Boy J Boogie for $1.99. He won't be convinced he needs attention. Peter's Prime for $5 Australian. Why the big problem with contrary evidence to flat Earth claims? What is so bad about being wrong? John Fisher do T-Net for £5. Team wants to convert JM. You should make it your mission to convert Sonny. I reckon it would be done if you keep at him. Hashtag save Sonny. Yeah, don't worry. Sonny's my boy. I'm going to save him. B-Boy J Boogie for $9.99. The chronic denial of Flerfs is textbook of attention-seeking behaviour. This mental gymnastics to dodge understanding isn't normal behaviour. Something isn't right in their personal lives. Ooh. B-Boy J Boogie for $1.99. I'm not misunderstanding, it's dodging understanding. And B-Boy J Boogie for $1.99. You only feel acceleration, dumbass. Yes, that's true. You don't feel constant motion. Wobbly nostrils for £2. Interesting. Indeed, interesting. Jonathan L for $7.99 Australian. Why would NASA allow private space companies to promote space tourism if they couldn't deliver and if NASA wanted to hide the shape of the Earth? It's kind of the NASA paradox, isn't it? NASA are this amazing company that have fooled humanity for 60 years, but also stupid enough to leave bubbles and people just disappearing off to the side. Yeah, they wouldn't, if they were trying to hide it, they would actually hide it. B-Boy J Boogie for $1.99. F bro. Rangerman 9404 for $2. Strike free called. N Flat Earth for $5. I think Nathan is so deluded that he thinks he's some kind of messiah. Yeah, Nathan is just wrong in the head. And Nathan wouldn't dare debate me again because he knows I will ruin him. I hope you're there, Nathan, and I hope you hear that, you coward. You would not dare debate me again. David Oliver for £2. OMG, eyes don't lie, explain optical illusions. Brian Bedazzle for $2. Wolfie6020 has video on his channel removing glare. Oh, I should have read that earlier, thank you. Better charge for $2 New Zealand dollars. Stop getting all the pie, Craig. I can't help it if pie's 3.141 and I want 3 of it. Jonathan L for $2.99 Australian. Sonny, please explain the Tanuska event.
Tanuska, I don't know that one.
Massive meteorite crashed in Russia, turn of the century, 1900. Wiped out like a massive forest and stuff. Was one of the most explosive asteroid impacts that we've had in recent years.
Interesting.
Where did it come from, I think is his point.
Oh, right. Oh. Could be a meteorite.
Yeah, but if it's a meteorite, where did that come from if there's a firmament?
That's a good question.
Very good question. Thank you, Jonathan L, for that. Stephen York for $7.99 Australian. He nods his head and says, interesting, but he was not absorbing anything you say. This is a waste of time. I think it's getting in. Bits of it are. Translator Carminium for $5. Stephen, you seem to have misconstrued Occam's razor. It only applies when explanatory power is equal. That's not the case with the flat earth. No, absolutely. Purger 1 for $2.99 Australian. Buy a welding shield for a few bucks and observe. Still not good enough as a solar filter, but better than a lot of things. Sirif for $5, in remembrance of Katie Johnson, a NASA mathematician and scientist that passed away at the age of 101. Yes, she did in the past couple of days. Amazing work that she had on that helped steer the Apollo missions and stuff based on her calculations. Robert Williams, $4.99 US. Each still has a focal length and exposure info. Video doesn't save either. D750 saves 30 megabyte files. 30 times 30 equals 900 megabytes a second to get the same data in a video. Yeah, there we go. JL Warren for $1.99. Prove it's not real, Sonny. No, flat earthers can't do that. God's Auditor for $5. Check out my Spy Me Sat app. You can track satellites going over your position and pay for tasking orders to have them take pics for you. It's cool. Ooh, that's awesome.
Wow.
Spy Me Sat app, Sonny, I think. Andreas Eldridge for 50 secs. Thank you for all the secs. I will have all the secs later. If Sonny wants to install a camera on the moon, I will lend him a ladder.
Jacob.
Draco Fire for $2. Free money, Craig. I'm running out of messages. LMAO. Thank you. It means the world. I do appreciate it. David Oliver for £5. For fuck's sake, proof equals not true. A lie equals oh. Must be right how flat earth brain works. Robert Gassman for $5. Start censoring flat earth nonsense. I'm trying to. It's hard. Jeff Roberts for $9.99. Thank you very much. Flat Earth Aussie Jesus, you owe me and several others in the chat $1,000. FTFE showed multiple pieces of evidence that the horizon doesn't rise to eye level. Pay us. Flat Earthers never pay up on their bets. We should learn this by now. And also, if you're watching, what was your name? Ace, you still owe Reds $500. Andreas Eldritch for 20 more secs. Ooh, lovely. Hashtag save Sunny. And Petermas Prime for $2 Australian. Thank you, FTFE. The meat tube is false. It is. That's Mandela. And David Oliver for £10. Thanks, FTFE, for this live chat. And thank you, Sunny, for actually listening and being well behaved. You woed me how well you behaved.
Wow. This is just normal behavior, but I don't know
not for flat earthers. That's the thing, Sonny. Most flat earthers don't know how to have conversations, as we saw with handlebar mustache guy. But yeah, guys, it's been a great night. Thank you very much. I appreciate you stopping by. On Wednesday, we have a debate at 5 p.m. UK time between Mr. Sensible and Mitchell from Australia. So that should be a good one. I'm looking forward to that a lot. And then possibly on Wednesday in the evening on Red's channel, JM Truth will be coming back to defend his claim that Red's Rhetoric's rocket launch footage is fake. And that'll be on Red's channel. And I'm sure there will also be some streams on Team's channel. I know Team's got a video coming out tomorrow, possibly. And my next video should be out either Wednesday or Thursday. Thank you very much for joining me. It's been a pleasure as always. Sunny, thank you for joining and having a decent conversation. Remember, everyone, stupidity is not a right. Fight the flat earth. Fight the flat. Fight the flat. Fight the flat.